GeeksforGeeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to yourself. GeeksforGeeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success. Commit with GeeksforGeeks. GeeksforGeeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success. Commit with GeeksforGeeks. GeeksforGeeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success. Commit with GeeksforGeeks.
Hello everyone, good morning. My name is Puneet Kansal. Welcome to the GATE Crash Course 2024. And in this session, I will discuss about the programming and data structure. So I will take a topic, in programming and data structure, and I will cover it in very depth so that you can solve each and every problem related to that in GATE exam. Okay, so at least I can confirm today that whatever the topic we will cover in this session, you will be able to attempt the GATE question. Okay, you will be 101%. You will be able to attempt solve that topic question in the GATE exam. Okay, that I will try to ensure. Okay, let me tell you. Okay, two type of people will get benefited from this session. One is who are preparing for the GATE exam from last 1 year. Okay, those people will definitely get benefit from this session because I'm going to cover lots of PYQs in this session. Okay, and you will enjoy. Means you will find out that okay, you are improving yourself, and you will ensure that okay, you 101%. Nobody can stop you to score the good full marks in these particular topics. Okay. Second type of student, okay, who have started the preparation later on, maybe very late, maybe even. So for those also, do not need to worry. I will be covering from very starting, okay, and I'm going till the end. So the starters also will get benefited from this session because whatever will be required to solve the GATE questions, I will tell you right now. Okay, there is no prerequisite for this session. So only okay, there is one prerequisite for this session. That is, I will ask you questions. Okay, in the complete session, 3 hours now, I will ask you questions, lots of questions actually, and you need to think over that. Okay, you need to think and reply. Think and reply. This you need to do. Right answer, wrong answer will not matter in this session. So what will matter if you are replying or not, if you are thinking or not. If you will do that, I'm giving you sure to here on live channel that you will be able to solve 101% all the questions related to that topic in GATE exam. So let me share my PPT with you people now, and let's proceed with the session itself. So just a minute, let me share it. Let me present my screen. Let me present my entire screen. Share it. And you people please confirm me that okay, I am properly audible and the PPT is visible to you people. You need to confirm me. Otherwise what will happen for next 3 hours? I will keep speaking and there will be no one, and people will think that this person is mad. They may think that okay, he's not speaking at all and continuing. Okay, so please confirm me. Please confirm me if I'm properly audible or not in the chat box. Any doubt is coming and you can mention in the chat box. Okay, I will take your doubts from the chat box. So let me also open the chat box here at my end. So please confirm me if I'm properly audible or not. Okay, so that we can proceed. Please confirm. Anybody, please confirm. Hmm. If anybody can confirm me, so I can proceed today. Otherwise, I am going to cover link list. Okay. So I have checked myself right now. So I think my voice is going properly. Okay, fine. Okay, fine. So let's proceed with this session, and let's start with the linked list, which is one of the most important topic in programming and data structure. One of the most important topic. People think that okay, this is some people think that okay, this is tough topic, but it's not tough if you will think logically. If you will go step by step, you will find that okay, you will start fall in love with the linked list actually. Okay, because this is a dynamic data structure, this is giving you lots of flexibility. Okay, and you will start enjoying it actually, because this give logical thinking, and whenever the logical thinking come, we as a human beings are very good at that. Okay, so let's make this linked list completely prepared for the gate exam. Okay, let's start. So I'm starting from very basic, so that you even if first time you are in first year, even you can understand the things. Even you are in first year of your BTech, you will understand, confirm, and you will be able to solve the gate question here itself. Okay, fine. So let's start with the linked list. Let's start with the definition itself. So a linked list is a linear. This is a definition. Okay, linked list is a linear but dynamic data structure in which elements are not stored at contiguous memory locations. Okay, not stored at contiguous memory location. Okay, so here I just give one definition. What do you mean by definition? Definition of something is actually I'm trying to represent this thing in one line, one or two line. That is the definition. And definition actually contains the important properties of that thing. Okay, important properties like linked list is a linear data structure. This is one property. Linear means elements are stored one after the another. First A is stored, then B, then C, then D. Okay, one after the another. Okay, array is also a linear data structure, but tree is not a linear data structure. Graph is not a linear data structure. Okay, linked list is a linear data structure because elements coming one after the other. You can access next element. First you will access A, then B, then C. One after the other elements are coming. It's not like graph randomly just coming anywhere. Okay, fine. Second property of linked list is it's a dynamic data structure. Dynamic means in which we can reserve the memory at runtime. At runtime, we can reserve the space. Okay. Array is not a dynamic data structure. Array is a static data structure. You need to define it initially. Okay, I'm not talking about vectors in C++. So right now, these days, we also have dynamic arrays like vectors or array list or list in Python. Okay, so I'm talking about okay, static arrays. So those cannot. We need to define their size initially itself. Okay, in the program itself. At runtime, we cannot define, but here in the linked list, we can reserve the space dynamically. Okay. Another property of linked list is that it's not storing the element in contiguous memory location. See, array is storing the element one after the another. Like if first element is at 100th location, B next element will be at 101. Next character is at 102. Next character is at 103. One after the another. Contiguous memory location in the array. Okay. But in the linked list, if one node is let's suppose I'm just taking any address. I don't know on which address these can be stored. They can be assigned any random address. These nodes. Okay. So 100 A is stored at 100 location. Maybe I don't know. B is stored at 150th location. I don't know actually. Next is 175. Next is I don't know. Maybe 300 or maybe 3000. So elements are not stored at contiguous memory location. In the counterpart, okay, array in array they were storing in contiguous memory location. Okay. Fine. So this is the definition of the linked list. So linked list is a linear, yes. Is a dynamic data structure, yes, in which elements do not store at contiguous memory location. That's it. That's it. Okay. Fine. Any doubt is coming to your mind, you can ask me anytime in the chat box. I will be keep checking the chat box. Your doubts will be more important actually, rather than any new information. Fine. Okay, please. Again, I'm reminding you, this session will be very, very useful if you will participate in this. Okay, if you will reply to the questions. Okay, then I can make you sure that you will be able to attempt every question in the GATE exam. Okay, so first question from my side. Let's suppose you have a singly linked list. Let's suppose you have a singly linked list. So this was the singly linked list. Okay, this is a singly linked list. Okay, in the singly linked list, okay, one node is just attached with another node. This is the structure of singly linked list, and this is one node. One node, every node have two parts. One is data. Here data, in data we are storing a, and another one is the next or pointer area, in which we are storing the address of the next node. So for example, address of first node is 1000, address of second node is 2000, here is 3000. I'm just randomly assigning any address. So this previous node having the address of the next node. So in this part we will store the address of next node, and this node is storing the address of next node, C node, I can say. Okay, 3000. So this link is showing that, okay, the address of this node is stored here in the next of previous node. Similarly, 4000 is stored here, and the last null is stored in this part. So a node is having two part. One is data part, and one is the link part. You can say link, you can say next, okay, whatever you can call, but this is storing the address of the next node. Okay, so this is a singly linked list. This type of linked list is known as singly linked list. Okay, fine. Can you tell me now, can you tell me, please tell me, what is the worst case time complexity to access one element in a singly linked list? Please keep replying. Right or wrong doesn't matter at all. Please reply. What is the worst case? In the worst case, what is the time complexity to access? I want to access one element. Okay, I want to access one element. What is the time complexity to access the element? Please reply. Right or wrong doesn't matter at all. Let's connect with each other. Let's connect with each other. Please reply. Whatever is coming to your mind, please reply. Please reply. Worst case, singly linked list, you want to access one element. Anybody? Is there anybody who can reply? Anybody? Otherwise, let me tell you. If you can reply, please reply. This will this will make our session very interesting. Fine. Otherwise, I'm going to this. We have a single linked list. You can ask me the doubt also. You can say I don't know also. Okay, we are here for learning. You just let's connect with each other. So the more you will reply, the more better we will connect, and the more better you will get the knowledge. I will be able to understand in how many depth I need to go actually. Okay. Okay, fine. So this is our single linked list. Fine. I want to access one element, and I'm talking about what is the worst case time complexity. Worst case to access one element. So in the worst case, I will access last element. I will try to access the last element. I'm talking about worst case. Okay, so I will give you the toughest job. So can you access the last element? Can you access the data? Then what you need to do, you will start from the head. You will start from the first node. I cannot jump directly to this node. This is not an array. In array, I can jump directly to any location in constant time. Okay, but in linked list, we need to start from the first location head, and we need to go step by step. We need to go one node to another, because every node is having the address of just next node. Every node is having the address of just next node. Every node is having the address of just next node. So if my linked list is having n nodes, that is having n nodes, then how many steps I will take? I will go 1 2 3 4. Here n is 4, so I will take 4 steps to reach over here to find this element, to access this element. So how much time I take? Order of n. 4 time in this case, or order of n time we take. Okay, fine. So I can write order of n time we take to access the element in a singly linked list. In worst case, that's it. Okay, Okay, you people tell me another question. Another question. Please keep replying. That is important. I want to search. We want to search an element now. We want to search one particular element. I don't know. I'm searching for E data. Maybe I don't know. So I'm searching for some element in the linked list. In the worst case, what will be the time complexity? Please reply in the chat box. Please reply in the chat box. Keep replying. Doesn't matter at all. You are giving wrong answer, right answer, because that should not matter in class. That should not matter in class. That should matter but in exam. Please reply. Please reply in the chat box. Okay, what is the worst case time complexity to search a element in a singly linked list? Otherwise, any doubt is coming, please ask that also. The more doubts you will ask, you are helping other people also. Okay, please reply in the chat box. Okay, people are replying. I was not opened it. Rajbir is saying order of n for worst case. Yes, Rajbir, you are right. Order of n for worst case. You are right actually. Fine. Saurabh is also here. Vikash is also here. Okay, great. Everybody, please keep replying. Fine. Okay. So we are searching. Maybe we need to go till the end in the worst case. Very good. Okay. We want to insert one element now in the linked list at the front. At the first position, we want to insert one element. How much time that will take in worst case? In worst case, in the starting, in the first position, I want to insert one element in the front. How much time that will take? Please reply. Please reply in the chat box. I'm checking the chat box now. Please reply. Search inserting element in the starting of the linked list. Keep replying, doesn't matter at all. What is your answer? Okay, so yes, Rajbir, you are right. That will take constant time to insert the element in the linked list, singly linked list in the starting. Take constant time. Why? Because I just need to create this new node. First I need to create the new node. Create new node. Okay, and that will take constant time to create a new node. Second thing, what I need to do, I need to link this new node with my first node. Okay, link new node with first node. Okay, this is second what I need to do. Again, that will take constant time. Okay, and last thing, I need to move this head now here. This is our new head now. Okay, we inserted a new node here. So third step is uh, shift the head. Okay, our head will be the new one. Okay, so this will also take constant time. Order of n plus order of n plus order of n. Total time complexity will be constant. Yes, you are right. Constant time. Okay, last question from here. Last question. Deletion from the front. We want to delete one element from the front. We want to delete. Saurabh, Rajbir, other people, please keep replying. We want to delete. Keep asking the doubts. Keep whatever doubt is coming to your mind, please ask. And let me tell you one more thing. The doubt which is coming to your mind, believe me, the question will come from there only. They cannot ask the silly question from you. They will ask from where you will stuck. This is gate exam. Okay, they will ask where you will stuck, where you will be having doubt in your mind. So don't hesitate to ask the questions also. Rajbir says that for deletion order of one time. Yes, Rajbir, you are right. Because what I need to do, okay, let me erase it. What I need to do, just one statement. I need to move my head. Head will be equal to head of next. That's it. That's it. So my head will be here. That's it. So this will be automatically deleted. That's it. We lost the address of this node. That means this is deleted. That's it. So order of one time to delete the node also. Great. On average case also, all will take the same order of n. So let me show you now in proper manner. This is also order of n. This is also order of n. In average case is same as worst case. In the case of singly linked list, this is 1, this is 1. You already tell me order of 1, order of n, 1 and 1. And space complexity is n. To store one node, one time, one space, and for n nodes, n space. Okay, fine. Fine. Any doubt you can ask me. Otherwise, okay, let's move on. Here is the structure of the node. This is how we define the structure of node in C and C++. Okay, in Java, we don't have pointers. Okay, so okay, fine. We define the structure of the node. You already know otherwise. So this is one node. This is our one node. In one node, we have data. We have data. So data can be character, integer, whatever is type. Right now we have character type data. Another part of the node is the next, which is a pointer, which is storing the which can store the address. Pointer can store the address of any other node. Okay, so only two things. So this is the structure of a node. Two things: data and next pointer. That's it. And we have a head pointer. Head will point, it will be having the address of the starting node. Let's suppose the starting node address is 1000. This will be having 1000, means this is connected with this. That's it. Fine. So this is how we reserve the memory in C language. Okay, in C++ and Java we use new operator. In C we use malloc operator, malloc function. Okay, so how this is reserving memory? Very easy actually. We are finding the size of a node. We are finding the size of a node, and we are telling, okay, just a minute. I think I need to connect the power cable. Give me a minute so that I can connect the power cable to my laptop. Just a minute. So okay, let me confirm also if I have connected it properly. I'm going back. Yes, it's connected properly. Fine. Let's move on. Okay. Okay, Rajbir is asking one question. Okay, Rajbir, I'm coming to your question. Before that, okay, let me wind up a little bit this thing and then I will come to your question. Okay, definitely. So I'm just telling how this is reserving memory. Simple. This operator, size of operator, is finding the size of a node, finding the size of the node, and this is telling, okay, maybe I don't know. This is telling, okay, we require 10 bytes. We require 10 bytes. He's telling to malloc. Malloc will say that, okay, let me reserve 10 bytes for you in RAM. He will reserve 10 bytes for us in RAM. Okay, 10 bytes in RAM. And let's suppose this is the 10 byte. This is the space given to us, 10 byte space, one node space given to us. Okay, and now the starting address of this node will be stored in the head. Head is a pointer, and this space is of type struct node. This is telling us about the type of space, means we will use this space for storing integer or character or something else. We will use this for storing a node. Okay, this telling what type of space we are reserving. This is reserving the space for us in RAM dynamically, and this is known as operator. This is not a function. Okay, size of operator is telling, okay, how much is the size of a node, so that we can reserve that much space to memory. That's it. Okay, so simple. We reserve the space in memory, and the starting address of that space comes to the head, comes to this pointer. Fine. Now, you people, please give me the answer. Here is a linked list you have with you. Okay, here is a linked list you have with you, and this is a temporary pointer I have taken. Can you tell me what will be the value of this PTR? What will be the value of this PTR? Meanwhile, I'm going backside. You can take the snapshot. Okay, you can take the snapshot, and I'm going back. I have one or two doubts. One is from Imran and one is from Rajveer. I'm taking those two doubts. Otherwise, other people can tell me meanwhile. You can take the snapshot and you can think over it. What should be the value of PTR? What should be the value of PTR? I'm going back first. Let me take the doubt of Rajveer. Rajveer was saying, sir, it's theta of n. Should not be it order of n. It's theta of n. Should not be it order of n. Actually, this should be, if we are talking about, see, first of all, let me give you two things. First of all, both are right. Let me tell you, this is also right, this is also right. Big O is also we can use here at this moment of time for linked list, and theta also we can use. Okay. Theta we should not use. Okay, let me tell you. We have to use big O only here. We should not use theta over here. Okay. Why we should not use theta over here? Let me tell you. Theta is actually telling us about the, we can use theta when best case is equal to worst case. When best case is equal to worst case, then only we can use the theta notation. Okay. Actually, theta is not representing the average case. Many people make the mistake that they think that theta is representing the average case. No, theta is used when best case time taken. Best case means minimum time taken. Minimum time taken by an algorithm, and worst case mean maximum time taken by an algorithm. If is same, if both are same, then we can represent it with theta notation. Okay, but here minimum time taken, okay, minimum time taken by an algorithm is for in the singly linked list is to access one element. In the best case, maybe I get in order of one time, because maybe the element is at the first position. If I'm searching one element I'm talking about, okay, one element, accessing one element, searching one element. Okay, so again, maybe the element is at the first position itself. Okay, so in these two cases, best case is different. Okay, so it's better we do not use theta. Okay, it's better we use big O only. Theta we can use for this case. For this and these two cases, we can use theta. Why? Because insertion in the best case and worst case at the front will take order of one time only. Deletion in the best case, in the worst case will take order of one time only. So again, that will be, we can represent both of them with theta. If you want to go in more detail, I just tell you. You just need to know one thing. We use theta notation when best case and worst case both are same. Here best case and worst case both will be same. Here best case and worst case are not same, so we should not use theta here. Theta is not allowed to use here. We can use theta over here. We can use theta over here. Okay, by the way, in this slide my motive was that, okay, what is the worst case time complexity, okay, to tell you that thing. Okay, but still if you want to go the difference between theta and big O, so this is showing the when both best case and worst case are same, then we use theta notation. Otherwise, if we have upper bound only, upper bound worst case only, then we use big O notation. Okay, fine. Average case, see, in average case also you can say that in average case this will take, you are asking, okay, this should be, sorry, it's theta of n should not be, no, see, in average case here you can write theta and here you can write big O. In average case you can write big O over here. Okay, you can write big O over here. Otherwise, because you are mentioning already average, this is not making impact. This is not, this theta and big O is not making impact, because you are already mentioning average over here. You specifically mention average, so you're specifically mention worst only. Okay, so that will not make the impact actually. Okay. Okay, fine. Still, if you have confusion in theta notations, like if we have big O notation, big omega, theta, small omega, then you can find out my lecture itself on our Geeks or Geeks channel. That will be little bit older. Okay, you can check out, you can find out. I can again give you guarantee that there will be no doubt in asymptotic notation. I'm giving you a guarantee. Okay, let's move to the link list right now. Let's move to the link list. Okay, and let me take one more question. Iman is asking, sir, hello sir, how are you? Happy to see you again. Imran, I'm also happy to see you again actually. Okay, fine. Fine, okay. So let's move on and let's focus on linked list. Let's finish this linked list. Fine. Okay, can you tell me what is the value of PTR? What is the value of PTR? Can you please tell me? What is the value of PTR? Please keep replying. Please keep replying. What is the value of PTR? If anybody can tell me. Good morning, Nishu. Good morning. Let's finish this linked list. Let's kick it away. We will finish it. There will be, they cannot ask the question from out of the syllabus, and we will cover everything and we will solve the question here itself in this class itself. You people will solve it. Just keep replying. Right or wrong doesn't matter at all. Doesn't matter at all. That should not matter in class. Okay, fine. Let me try at my end. Let me try at my end. I'm going very easy way. Okay. So head is storing the address of first node. Okay. Okay, fine. Head is storing the address of first node. Fine. Head of next. This is the next. This is the next. This is the data. Okay. We already discussed. This is the data part. This is the next part of a node. In every node, this is happening like this only. This is data. This is next. Okay. Now head value is 4800. What is the head of next? Head of 4800 next is 4900. Fine. 4800 next is 4900. 4900 next. 4900 next is 5000. So we are just storing 5000 in PTR. We are storing 5000 in PTR. Fine. We are storing 5000 in PTR. Can you give me the answer of another question? Please give me the answer of another question. What will happen after executing this statement? Now the PTR value is 5000. Now the PTR value is 5000. Can you tell me what will happen after executing this statement? Please keep trying. Keep trying, keep replying. That is the mantra. Please keep trying, keep replying. Please keep trying. Doesn't matter at all. You are giving right answer or wrong answer. And there's a reason why that doesn't matter. Because the moment you try, the moment you will try, confirm, learning will happen. Confirm, learning will happen. Either wrong or right answer doesn't matter at all. Learning will happen. And that's why we are here. Keep trying, keep replying. Keep trying, keep replying. Please. Please. Waiting for your answer. Waiting for your answer. Not worry, Nishu. I will give you more harder question. Don't worry. I will spoil your life. Yes, yes, Nishu, you are right. This will make a circular linked list. Okay, let's see what this statement is doing. Let's see it. Let's see it. Okay. PTR value is 5000. We know this thing. We already calculated over here. PTR value is 5000. Fine. Now we are checking what is the next of 5000. This is 5000. This is the next of 5000. That is 3000. And what is the next of 3000? What is the next of 3000? Next of 3000 is this space. This space. See, this part is at the left hand side. So whenever I'm at the left hand side of anything, of any statement, I will store some data at that place. I'm not accessing null over here. I'm talking about this space, this area. And in this area, I'm storing the address of the head. Okay, I'm storing the address of the head. Address of the head, not address of the head, value of the head. Value of the head is 4800. So I'm storing here. Let me erase it. And let me store over here. Let me store over here 4800. The moment I store 4800, actually I have linked this node with the first node. I have linked this node with that first node because this is the address of first node. So we are actually doing this thing with this statement. And what is this? We are creating the circular linked list. We are creating the circular linked list. Fine, fine. The people who are trying 100% sure they will be getting what I'm talking about. Confirm. That is confirm. Okay. Tell me what is the output of this statement. This is printing something. What this is printing? What this is printing? Can you tell me? Can you tell me? Please try. Can you tell me what this will print? Please try. Confirm. Confirm, Rishikesh. You will definitely run. You moment you will reply, you will definitely get what I'm talking about. But if you are not replying, there may be a chance that okay, you are not getting. Okay. Still, we can ask the question. Still, we have one thing with us. We can ask the question. You can stop me anywhere. Your questions are more important than any new information because the question is coming from there itself. So it's better to ask it and help the other people also. Keep trying, keep replying. Keep trying, keep replying. Rajbir is saying head will be printed. Kunal is saying 10 will be printed. Rishikesh is saying 20 is printed. Nishu is saying 10 will be printed. Okay, let's see what that will print. So our head value is 4800. We know this thing. Head value is 4800. And what is the next of 4800? Next of 4800 is 4900. Fine. 4900. And what is the next of 4900? Next of 4900 is 5000. Okay, fine. And what is the next of 4000? 5000. That is 3000. Fine. So what is the next of 3000? Next of 3000 is actually right now 4800 is stored over here. Right now 4800 is stored over here. So this is 4800. And what is that next of 4800? Oh, sorry, not next. That is data. What is data at 4800? That is 10. That is 10. So we are going to print 10 value. We are going to print 10 value. So although if you know C, we use D for printing the integers, and 10 is an integer over here. We are not printing the address. Okay, fine. So this will print 10. This will print this value. We are going one by one to other node, other node, other node, and after this we come to the first node, and there we print the data. There we print the data. Fine. Okay, one last question from this slide. Now forget about the circular linked list. Forget that. Okay, we have executed these three statements. Okay, we don't have circular linked list. We have this linked list. We have this linked list only. What will happen after executing this statement? Can you tell me what will happen after executing this statement? What will happen after executing this statement? Let's suppose we don't have circular linked list. We have this linked list only. Okay, this is given right now. What will happen after executing this last statement? Last statement. Keep trying, keep replying, doesn't matter at all. Don't worry about other people and that, okay, if I'm giving wrong answer, then what will happen? Nothing will happen. They cannot do anything with us. Say proudly, I'm making what you can do. I'm making mistake. Yes, I'm making mistake. I'm learning. Okay, okay, one question also we have from Saurabh. Fine, I will take that. But let me see answer first. Keep helping each other also. That is also great thing. That is great thing if we are helping it to each other. Head of the linked list will be deleted. Head of the linked list will be deleted. Delete nahi hoga. Memory leak hoga. What will happen? Just I move the head over here. Just I move the head over here. That's what is the head? Head is 4800. What is the next of head? Next of head is this 4900. So we store 4900 in the head. Head is now having 4900. 4900. This means head is pointing to this node. Actually, we deleted this node. We deleted this node. One thing. We deleted this node. If we are using, okay, if you are using C or C++, then you can say an issue here, memory leak is happening. Means this node is in memory, this node is in memory, but we are not able to access it because we don't have this address now. We don't have this address now. Okay. But in the case of Java, we have garbage collection. We have garbage collection. So we do not need to delete this memory separately. We do not need to delete this node separately. Just one statement will work to delete the first node. So this statement is simply deleting the first node. That's it. That's it. Okay. So one thing I can say, this is deleting first node. Our head is pointing to the next node. That's it. Okay. If you are a C++ programmer, better you delete this from memory, from RAM, okay, by providing the address of this node in a temporary variable. But in Java, we do not need to do that only, that itself. Okay, fine. So simply we are deleting the first node here. Okay, fine. Let me take one or two question. Like Kunal was asking, head of the link list will be deleted. Yes, Kunal, you are right. And Nishu, that will be 4900. Yes. How it's storing 4800? So I think Saurav is asking from previous one. Head is storing 4800. That is already storing 4800. Okay. And and so okay, Rajbir, one thing let me tell you. This this will be deleted from the link list. This will be deleted from the link list. Your head will be here. Your head will be here. Now you cannot access this node. You cannot access this node. Again, I'm clarifying this thing. If you are using C and C++, then this will remain in RAM. This will remain, this node will remain in RAM. Okay, this will, it's like, it's this concept is known as the pointer, which is this address, or this pointer is known as dangling pointer. What that is known as? Dangling pointer. Like this pointer is like it's dancing and saying, I'm here, somebody listen to me. But we cannot listen. He will keep dancing. We cannot listen. We don't know what its address is. We cannot access this element anymore. We cannot access this element anymore. Okay, so because we cannot access this element from here, okay, in this linked list, we cannot access that until unless we do not store it somewhere in another variable. I'm not storing it in another variable. I'm just executing this statement. So what we will say that, okay, this node is deleted. Okay, this node is deleted. Although node is available in RAM, but for us, for this linked list, this node is deleted. We cannot use it again. We cannot access it again because we don't have the address of this. And in Java, it's here we need what we can do to delete it from the RAM also. We can use the delete operator, and we can pass its address, and this memory will be free. Okay, so that other programs can use the same memory. Okay, in Java, we do not need to do that also. Java will do garbage collection all by itself. That's it. Okay, fine. That's it. Fine. Let's move on. Now we have let's do some operations on linked list. Let's do the operation like traversing of the linked list, insertion in the linked list, deletion in the linked list. Okay, so let's traverse the linked list. Let's traverse the linked list from starting to the end. We want to print all the element of the linked list. Okay, we want to print all the elements from the linked list. What I need to do? Simple. I need to set a loop until unless I will not reach to the null. I will keep accessing the data at every node. Okay, or I will be printing the data at every node. So I write a program for you people. I write a program. So please check out. Is this code will work fine? Please verify. Please verify. Is this code will work fine to print the data of all the nodes? Traversing means we are going through all the nodes. So until our head is not null, we are printing the data. We are printing the data. So please find out, is this the right way to print the data of all the nodes, or do you want to make any change in this code? Do you want that, sir? You should make this modification in this. That is not a good idea. Or otherwise check it. So what I'm doing, okay, in this code is I'm moving my head till the null. Okay, this loop is going, yes, this loop is going until unless I don't get null. And I'm printing every time the data. Yes, this is also happening. I'm printing the data and I'm moving the head every time next, so that I can print the next data until my head is not moving to the null. So do you think that this code is working fine, or you need to do, you want to improve it? You want to improve it. How many people are saying, okay, this code is working fine, right? Yes. The people who are saying no, who think that no, we need improvement, say no in the chat box. Please write. Please write in the chat box. If you think that we don't need to make any modification, it's working fine, simply say yes. And if you feel that no, there should be some modification in this, then you write no first. Okay, and then write the reason also. Then write the reason if you are saying no. If you're saying no, write the reason. And we get the reason actually. We get the reason from Kunal. Kunal is saying that, and Nishu is also saying the same thing. Yes. What will happen actually? First of all, the answer is no. This is not the right way. This is not the right way to traverse the linked list. One modification we need to make. And what is that? What is the problem occurring if I'm using this code? The problem is that somebody asked me, can you please traverse the data? Can you please read the data for me, which is in your database? And you write this code for him. You write this code for him. Actually, you lost their data. What will happen after this executing this program? What will happen? You will lost the linked list. You will lost the linked list. After executing this program, your head will be here, and when your head will be here, you cannot access these elements. You cannot access your linked list. This is not the right way. Somebody asks you to access the data from the database, and you say that okay, you can access the data, but one time only in your life. This is not the right way. So what we can do, what we can do, you already given the answer. You already given the answer that take a temporary variable. So take a temporary variable and then move that temporary variable. Don't touch the head. Head should be remain here only. Otherwise, if you will lose the head, you will lose the linked list. Okay, because head is storing the address of first node, and first node is storing the address of second, third, so on. So if you will lose the head, you will lose the linked list. So it's better take a temporary variable and move this temporary variable and keep checking the data. Move this temporary variable until that do not reach to the null. That's it. Yes, you people are right actually. We need to take a temporary variable. So I take a temporary pointer PTR, store the address of head in the PTR, and now I'm moving the PTR. I'm moving PTR. I'm moving PTR. I'm not moving head now. So PTR will reach to the end. PTR you can say, or temporary pointer you can say, whatever name you can give. So okay, just one modification we need to make here is that we will not move our head. If we will move our head, we will lose our linked list. Okay, so it's better take a temporary variable, move that, access the data with the help of that temporary variable. So we are taking a PTR temporary variable, accessing the data with the help of that, and moving that itself. Fine, great, great. So this is not the right way. That is the right way, right one. Okay, fine. So traversing we have done. Let's now perform the insert operation. I'm just going through all the concept, let me tell you. And after going all the concepts, you will be able to solve all the question. That's it. That's it. And we will solve the question here itself from the gate and from the ISRO also. Okay, and you people will solve actually. If you will understand this thing logically, if you will able to get these things. Any doubt is coming, write in the chat box. Fine. Let's move on. Let's insert a new node. This is our new node. We want to insert it at the front of the singly linked list. So this is our singly linked list. We want to insert this node at the front. Okay, and how to insert? Very easy. Just whatever is the address of this node, we'll store here. Okay, and this will be linked with this. Fine. And then we will attach the head. We will say that this is our new head. This is our new head. That's it. That's it. Constant time this will take. How much time? Constant. You already tell me. Insertion at the front take constant time to insert. Fine. So I'm giving a code to you people. I'm giving a code to you people. What I done? I just assign this head. This my head is pointing to new node. Okay. And the next of this new is this place. At this place I'm storing whatever is the value here, 1000. Okay, okay, I just write these two statements I need to write. Please check, tell me, please verify, is this right or wrong? Do you want to make some modification? Then write no in the chat box. If you feel that yes, it's working fine, then write yes. Think over it. That is learning part. Think over it. Think over it and reply, please. Think over it, please reply. Please reply. And if you are finding this session helpful, please give a thumbs up. That will motivate me to come up with new sessions if you'll find more thumbs from you people, please. Okay. So write yes if we are finding this code working fine. If you're finding there is some problem, please write no. Give me the reason also. And the reason is provided by Nishu. Right now we have 3 hours time. Okay, in 3 hours time, I will first try to finish the link list. Okay, so I don't want to lie you people. We cannot finish complete programming data structure in 3 hours. Okay, if you really want to go step by step, if you want to make sure that you should be able to attempt question in gate exam, then I need to take you step by step. That is I'm taking, and you will solve it here itself. And covering the complete syllabus, sorry, is not possible in 3 hours. Okay, so but still okay. You can find my video if you really want. That is already recorded and available on GeeksforGeeks YouTube channel. You can find out over there. If you want to find in more detail everything, then that is no doubt that is paid course by the GeeksforGeeks. Okay, so I don't want to tell anything wrong over here. Okay, fine. Okay, okay. So some people are saying no, and already the reason why the people are saying no, they give me one reason. What is the reason they're giving? They're saying that, sir, although you are performing these two operations, we need to perform these two operations. We need to link with this to this, and we need to change our head. Okay, but you cannot do this in this sequence. You cannot do this in this sequence. Why I cannot do this in this sequence? According to this sequence, what I'm doing first, I'm first assigning my head here. The moment I will assign the head over here, I will lost my linked list. I lost the address of my first node. I lost the address of my first node. Let's suppose the address here is 500. So now head is storing 500. The moment I lost this address, I lost complete linked list. Okay, so first what I need to do, it's better I perform this task first and then this task. So let me perform, okay, this task first. So what will happen now? New of next, the next of this new is this. Here I'm storing what? I'm storing the address of the first node. Let's suppose 1000. So I'm storing 1000 over here. So this will first link this. Then it's better to execute this statement. Then execute this statement. So sequence of these statements should be like this. First this should be executed, then this. Otherwise we will lost our linked list the moment you will execute this statement. Okay, fine. So I can say that don't write this statement over here, write it over here. That's it. Shift this statement downside. First execute this, then this. That's it. Now it's working fine. Now we can insert in the front of the linked list. Fine. Okay, let's insert at the end of the linked list. End of the linked list. There is a new node. There is a new node, and I want to insert it here. Okay, let me create the new node over here. So that is little far away here. Let me create it here. Let me give some other data also, DE. Okay, so how to insert at the end? First of all, whatever is the address here, let's suppose 5k. I will store 5k here. This will be link with this node, and I will store null over here. That's it. This is what I need to do. I need to store 5k here, and I need to store the null over here. Can you tell me in the chat box? Can you tell me in the chat box what is the time complexity to insert the node at the end of the linked list? What is the time complexity to insert the node at the end of the singly linked list? Can you write in the chat box? Doesn't matter at all. You are giving right or wrong answer. Meanwhile, let me go through other comments also, which I have not read. Yes, Nishu, but yeah, you are right. I do not teach complete algorithm because that was not possible. Sorry, in 3 hours that is not possible. Rajvi Rathore is saying और बाकी के recording डाल देना if not already available. होगा उतना कवर करेंगे सर. Great, जितना होगा उतना कवर करेंगे. इतना कवर कर देंगे. जो कर लिया वो फिनिश. कहीं पे जाने की जरूरत नहीं है. लिंक लिस्ट खत्म. लिंक लिस्ट खत्म, कहीं पे जाने की जरूरत नहीं है आपको, कोई कोर्स लेने की जरूरत नहीं है, कंफर्म कंफर्म। Kunal, you are right. This will take, yes, Rishikesh, you are also right. Order of n time, yes, Nishu. Order of n time, because you know this will take order of n time, because you people know that. Although storing the address of this new node here will take order of one time. Although marking here null will also take order of n time. Fine, but to store this node at the end, you need to traverse from the head. I cannot jump directly here. I cannot jump directly here. This is a linked list. This is not an array. This is not an array. In array, I can store an element in constant time wherever you want, wherever you want. But in the linked list, you need to go. We need to start from the head, step by step, step by, because this person don't know the address of last person. This only know the person of address of second person. Second person only know the address of third person. ओके, एंड थर्ड पर्सन ओनली नो द एड्रेस ऑफ नेक्स्ट पर्सन। तो पूछते पूछते ही जाना पड़ेगा अपने को, कोई रास्ता नहीं है। इफ यू आर कंफर्टेबल इन हिंदी ऑल्सो, आई कैन प्रोसीड इन दैट ऑल्सो टू कनेक्ट विद यू पीपल बेटर। इफ एनीबडी इज नॉट कंफर्टेबल इन हिंदी, write in the chat box. I will not use Hindi. Otherwise, I want to connect with you people much better way. Let's use our mother tongue also, English, Hindi, both. If you are comfortable, if anybody is not comfortable, then I will move in English only. So please let me know if anybody is not comfortable in Hindi. Otherwise, I just want to connect with you in a better way. Okay, fine. So traversing from starting to the end will take order of n time. मेरे को लास्ट नोड पे आना ही पड़ेगा भाई, मेरे को लास्ट नोड पे आना ही पड़ेगा, क्योंकि मेरे को इसको अपडेट करना है, मेरे को इसको अपडेट करना है, तो लास्ट नोड पे तो आना ही पड़ेगा। लास्ट नोड पे आने के लिए एन टाइम लग रहा है, लास्ट नोड पर आने के लिए एन टाइम लग रहा है। उसके बाद ठीक है, दो ऑपरेशन करने हैं अपने को। एक ये एड्रेस यहाँ पे डालना है, डाल देंगे, कांस्टेंट टाइम लगेगा। इसमें नल डालना है, डाल देंगे, कांस्टेंट टाइम लगेगा। ठीक है, टोटल टाइम लेकिन जो लगेगा ऑर्डर ऑफ एन, क्योंकि वो ट्रेवर्स करने में लग रहा है, क्योंकि वो ट्रेवर्स करने में लग रहा है। इफ एनीबडी इज नॉट कंफर्टेबल इन हिंदी, let me know. I will speak in Tamil also. No, I don't know Tamil. Okay, fine. ठीक है, तो दिस ये ऑर्डर ऑफ एन टाइम ले रहा है, क्योंकि ट्रेवर्स करने में टाइम लग रहा है अपने को। ठीक है ना, ठीक है। तो मैंने एक कोड लिखा है, वी राइट अ कोड ओवर हियर, प्लीज चेक आउट इज दिस वर्किंग फाइन और नॉट। अभी तो मैंने क्या किया, पिछले वाली प्रॉब्लम, पिछले जो पीछे में हम कवर कर चुके हैं ना, वो प्रॉब्लम तो मैं नहीं क्रिएट कर रहा हूँ यहाँ पे। अभी मैं देखो अपने हेड को मूव नहीं कर रहा हूँ, लास्ट तक पहुंचने के लिए ना हेड को मूव नहीं कर रहा हूँ, अलग से मैंने एक पॉइंटर ले लिया, उसको मूव कर रहा हूँ। और जब तक वो पॉइंटर नल नहीं हो जाता, तब तक मैं उसको नेक्स्ट नेक्स्ट किए जा रहा हूँ। उसके बाद फिर मैंने क्या किया, इसको न्यू से कनेक्ट कर दिया, न्यू नोड से मैंने इसको कनेक्ट कर दिया, ओके, यहाँ पर, और उसके नेक्स्ट में नल डाल दिया। फाइन। Do you think that this code is fine? Write yes. If you feel that this code is not fine, write no. If you feel that this code is fine, write yes. If you feel that this code is not right, write no. Please reply in the chat box. Keep replying. Keep replying. If you're finding this session interesting and useful for you people, please give a thumbs up. That is actually, that will motivate me to come up with more sessions. If you're finding this code is working fine, write yes. If you find there is some problem in this, then say no. But with no, please share the reason. Please share the reason. If you're saying no, please share the reason. You people can write in the comment also. If you're finding this session helpful, please write in the comment right now itself, because the more will be the comment, the more will be the thumb. Actually, this will reach to more people. Okay, and that really motivate us, really motivate us. Believe me, the money the Geeks for Geeks is giving me, that not motivating me that much. Okay, and this thing is motivating me more. If you're giving thumbs up, if you're writing in the comment, okay, Fine, okay. Okay, so the reason we get Kunal is saying that this, sir, there is a problem with this statement. There is a problem with this statement. Please replace this statement. Please replace this statement with this statement. So he wants me to replace this statement with this statement. Why he wants me to replace this statement with this statement? Because ये ऐसा ही है, ये ऐसा ही है। देखो मैंने यहाँ से स्टार्ट किया था पीटीआर अपना, पीटीआर यहाँ से स्टार्ट किया, पीटीआर को पहले हेड के इक्वल कर दिया। जब तक पीटीआर मेरा नल नहीं हो जाता मैं आगे मूव करता जा रहा था। मेरा पीटीआर यहाँ पे आया, लूप के अंदर हम मूव कर रहे हैं, आप नेक्स्ट नेक्स्ट करते जा रहे हैं पीटीआर को। पीटीआर यहाँ पे आया, पीटीआर यहाँ पे आया, ठीक है। ओके, लेट मी इरेज दिस लिंक राइट नाउ एंड दिस नल ऑल्सो। तो पीटीआर यहाँ पे आया, अभी नहीं रुके हम, अभी नहीं रुके हम कहाँ पहुंच गए? जब तक पीटीआर नल नहीं होता। तो पीटीआर यहाँ पे पहुंच गया। अरे पीटीआर हमें छोड़ के चला गया, पीटीआर आगे निकल गया, मतलब हमें तो यहाँ पे रुकना पड़ेगा, हमें यहाँ पे लास्ट नोड पे रुकना पड़ेगा। ओके, लास्ट नोड पे रुकना पड़ेगा, वो उससे भी आगे निकल गया, वो नल पे निकल गया, ठीक है। तो पीटीआर को यहाँ पे लास्ट नोड पे रोकना है, लास्ट नोड पे, क्योंकि अपने को इस नोड को अपडेट करना है, यहाँ पर अपने को न्यू नोड का एड्रेस डालना है, तो यहाँ पे तो रुकना पड़ेगा ना। यहाँ पे रुकने के लिए एक स्टेप पीछे से, यहीं से देख रहा हूं मैं, यहीं से इस स्टेटमेंट की हेल्प से हम यहीं से देख रहे हैं, क्या इसका नेक्स्ट, क्या पीटीआर का नेक्स्ट, क्या ये, अगर ये जब तक ये नल नहीं है, मतलब हम यहाँ पे जाके नहीं देखेंगे, नल के पास जाके नहीं पूछेंगे भैया आप नल हो, नहीं, उससे पहले ही हम पूछ लेंगे क्या आपका नेक्स्ट नल है, क्या आपका नेक्स्ट नल है, तो हम रुक जाएंगे। तो इसमें हम इससे यही पूछ रहे हैं, क्या आपका नेक्स्ट नल है? वो कह रहे हैं हाँ मेरा नेक्स्ट नल है, तो ठीक है हम यहीं पे रुक जाते हैं। पीटीआर अब हमारा यहीं पे, हमें यहीं रुकना पड़ेगा लास्ट नोड पर। लास्ट नोड पे रुकने के बाद बस ठीक है, उसके बाद हमने उसके नेक्स्ट में, इसके नेक्स्ट में, पीटीआर के नेक्स्ट में न्यू डाल दिया। न्यू मतलब न्यू में एड्रेस है इस नोड का, मे बी आई डोंट नो 5K, तो 5K हमने यहाँ पे डाल दिया इस स्टेटमेंट के थ्रू। और अब जो हमारा न्यू का नेक्स्ट है ये वाला पार्ट, इसको हमने नल कर दिया, ठीक है, ये हमारा लास्ट नोड बन गया, क्योंकि हो गया कनेक्ट ये, दैट्स इट। सो इस स्टेटमेंट को इस स्टेटमेंट से रिप्लेस करना पड़ेगा, दैट्स इट। सो राइट कोड विल बी दिस, जस्ट वी रिप्लेस दिस स्टेटमेंट with this another statement, that's it. Fine. So this is not working fine, this is working fine. Okay, now next operation. So let's insert at the middle, of the singly linked list. So we want to insert a new node after a node which is having B data. So actually I want to insert the node in between B and C. In the middle I want to insert in the singly linked list. Can you tell me, okay, first of all, can you tell me please, what is the time complexity to insert at the middle of the linked list? What is the time complexity to insert at the middle? Please keep replying. Okay, Rajveer, I will try to keep it mostly in English. Okay, mostly. Okay, can you please tell me what is the we want to insert at the middle. Okay, so what is the time complexity? What do you feel? What do you think? Just tell. It's okay if you are telling wrong or right, doesn't matter in class. If you are in college and you are giving wrong answer in your class, and if your professor is saying something to you, you can use this statement. You can say that this doesn't matter in class, this doesn't matter. Okay, you can stand up and you can say this thing. Okay, fine. And you can blame me. You can say that, sir, Puneet sir was saying this thing. We are not responsible. Please catch him. He is saying on the YouTube itself, in the front of lakhs of people here, making this statement. Okay, you can blame me. Fine. Okay, you people are right. Actually, this will take order of n time, because you people know that inserting this node, what I need to do, I need to attach this with this and this with this. Both will take constant time. This will also take constant time. Linking this will also take constant time. So why you are saying order of n? Because you know that you need to come in the middle, means at n/2 node you need to come. So to traversing from the head to the middle will take order of n/2. Order of n by 2, and 2 is constant. 2 is constant, so that will take order of n time. That will take order of n time. Okay, fine. So let's do it. Let's do it. So let's suppose, let me do it by putting the addresses over here. So let's suppose the address of this node is I don't know, 3k. Let's suppose this is 4k. Let's suppose this is 5000, 5k. What I need to do, I need to store the address of this new node here. So now this is linked, and I need to store the address of this node here. This is also linked. Okay, and before that I need to traverse till this node, till b I need to traverse. Okay, so I will put a loop, I will traverse till b node. Okay, and then I will make these two link. That's it. Okay, so here is the code for that. I'm taking a temporary pointer. I will not move my head now. I will not make this mistake again. I will not move my head. If I will move the head, I will lose the linked list. So okay, I'm taking a temporary pointer until unless I'm not getting b data. See, I'm also not making the mistake of going further. I'm using this statement. I'm checking here itself, PTR data. That should be, until unless that is not b, I'm moving. The moment that is b, I will stop. I will come out of the loop. So I reach here. With the help of this loop, I reach here. We reach here. Okay. And after that, what we are doing is simple, making two links. One is this link, one is this link. That's it. So please check out. Please check out this code is working fine or not. Please write in the chat box what you think. What you think. This is working fine or not. Please verify and reply in the chat box. Please verify and reply in the chat box. If you are saying no, you can say no, but with the reason. You need to give the reason. Okay. Otherwise, say yes. Otherwise, ask doubt also. Doubt are also very important. See, doubt is not helping you only. Believe me, the doubt is helping lots of other people also. Because you people are at the same level. If doubt is coming to your mind, that will be coming to many, many students also. If you are asking it, that will be resolved not only for you, that will be resolved for many people. So please keep helping other people also. Keep asking the doubt, please. Yes, Kunal, you are right. This is not working. This is not working. And you are right. Your reason is also right. Your reason is also right. And what is the reason? Let me tell you. He already gave the reason. He is saying that, sir, the problem is here. Please change the sequence of these two statements. He's asking me, please first execute this statement, then execute this statement. Let me execute this statement first. Let's see what wrong will happen. So this is our PTR is here. After this loop, our PTR is here. Fine. Okay. What we are doing in the PTR next means at this place, we are storing the address of new node. So let's suppose that is 3k. We are storing 3k here. The moment we store 3k here, this is linked with this. The moment this is linked with this, the address of this node, let's suppose that was 4k. This was here actually earlier. That is lost. That is lost. Now we don't have this address at all. This link is lost. The moment you execute this statement, this link is lost. This complete list will be deleted. It's like this complete list will be lost because we cannot access now. We don't have the address. How we can access now? Okay. Even they will be keep crying. We are here. We are here. They're in memory. They're crying. They're shouting. Let them keep shouting. Nobody can listen to them now. They're in memory, but nobody will listen to them. Okay. So we cannot access them. Okay. So what we can do? So Kunal is saying that, sir, shift the location, shift the position, shift this statement downside. Okay. Shift this statement downside. So let's shift it. So let's shift it. That's it. So shift this statement downside. That's it. Execute this statement first. Means first in the new next here, store the address of this node. So let's suppose this is 4k. Store 4k over here. Okay. Our PTR is here. Okay. We also have address of this node. Now we can store, okay, let's suppose the address of this node is 3k here. So first this must be executed. This link must be established. Then this link. Okay. Fine, I hope that is clear. Fine, great. Now, next operation. Let's perform the deletion. Let's perform the deletion. Insertion we have done at the front, at the end, at the middle. Okay, let's do the deletion now at the beginning of the singly linked list. ओके स्टार्टिंग में करना है, स्टार्टिंग में लिंक नया नोड डिलीट एक नोड को डिलीट करना है, इसको डिलीट करना है, क्या करना है, कुछ नहीं, हेड को मूव कर दो, हेड what we can do, head is equal to head of next, so head will be here, and can you please reply in the chat box, is this okay, yes or no, or do you want to still improve it, is this okay? And Nishu already improved it. Nishu says that, sir, might be you are using, because this is a gate exam, you are more C language specific, gate CS I'm talking about, gate CS, although you can use this same concept for gate AI also, but in gate AI they will be using Python, that's it. I have seen that, okay, if you will check out the sample paper, most of the question in DSA, they gate AI I'm talking about, if you have filled the gate AI, then most of the question, even though they mentioned, okay, they will use Python only, they will not use C, C++, Java, any other language, but before DSA purpose, they are asking the question in pseudo code, pseudo code. Okay, so what I want to say, the same concepts will be used there also. Okay, if you are preparing here, you are preparing for gate CS, you are actually preparing for gate AI also. DSA is prepared for both of them. Okay, little modification might be there, that okay, they might use somewhere Python code sometime. Okay, might be. Okay, in sample paper they asked the question in Python, but that they were related to the Python, not more specific to the DSA. They were related to the language itself, Python. Okay, so I'm saying that this same logic, same thing, same DSA will be used for preparation of both these exams. Okay, fine. So we get the answer of this. Simply, Nishu is saying that, sir, take a temporary variable, store the head address in this temporary variable, then you can move your head. Now you have the address of this previous node, your head is moved here. After executing this statement, your head is moved to the next. Now you can free this space, and the address of this node is in this temporary pointer, and please free this, so we can use delete, we can free it. Okay, so there is a delete function in C++, and we can use delete with that in C++. In C we can use with, we can free, we can this pointer. Okay, fine. So simply just I'm saying that free this space. This is a noble practice, I can say. This is a noble practice. Although this is not mandatory, but if you are, this will actually, okay, let me tell you why this will be a noble practice, and this is a good practice. If you are applying for service-based company, okay, like TCS, Infosys, and all that companies, okay, then they will accept this answer. They will say you are good to go, you are welcome to our company. But if you are applying for product-based company, like Amazon, Google, Flipkart, whatever, okay, so if you are applying for a product-based company, then they will not accept this thing. These people will accept this person only, they will hire this person only, they will not hire this person. If you are specifically talking about C and C++, in Java this will also work, because garbage collection will happen automatically. Fine. I think you have to focus on both the exam. You can take the benefit right now in both the exam. I don't know right now if you have filled or not. So it's okay if you have not filled, then no need to think over that. If you have filled, then I think that is advantage, because most of the things are same. Fine, it's okay. That is another topic to discuss. We do not need to worry. Even we clear one of the exam, that is good to go. That's it. Fine. Some more statements I do not share with you people. Initial condition. So can you tell me what this condition is doing? What this first condition is doing? Can you please write in the chat box? Can you please write in the chat box what this initial condition is doing? What this initial condition is doing? Can you please write in the chat box? Can you check out what this mean is? Means there is no node. Yes, this is checking if there is no node. Head is null. Head is null. इसका दिमाग खाली है, इसको आप ऐसा बोल सकते हो, दिस हैव एम्प्टी ब्रेन. ओके, नो नोड इज देयर. ओके, एंड व्हाट यू मीन बाय दिस? What you mean by this? What this statement is doing? Second one. Yes, Kunal, and yes, Rajveer, sorry. Can you tell me what this thing is doing? Yes, this is telling us that okay, there is one node. Means in the head next there is null. If there is null in the head next, there is no more node over here. So there is one node in the linked list. So we can, in the case of deletion, if there is no node, simply return there is no node. Somebody asking you, okay, if I'm asking you, please delete one node. There is, when head is null, there is no node in the linked list. There is no node in the linked list. I'm asking you, can you please delete one node? You are saying that there is no node, I cannot delete. I'm keep replying again and again. Please delete one node. Delete one node. What you will say? You will say that, sir, are you okay? There is no node there is no node at all. How we can delete? We will simply return. And when there will be one node, just delete that and make the head null. That's it. Okay, fine. Let's move on. So let's now delete the last node. Delete this end node. How much time we will take? Please reply in the chat box. How much time we will take to delete the last node? Please reply. Control yourself. Rajveer, please control yourself. Please reply to this. Order of n. Yes, you people are right. This will take order of n time. Actually, deleting this node means inserting null over here. That's it. Inserting null over here. This will take constant time to insert null over here. So why these people are saying order of n time? Because they know that to delete this node, I need to reach at this node. And to reach to this node, I need to come from the very starting. So I need to go to n-1 steps. So moving to the second last node actually will take order of n time. Moving to the second last node so that I can insert null over here will take order of n time. Deleting means storing null over here. That's it. Or you can free the space also. That is again also take constant time. So moving to this position will take order of n time. Deleting it will take constant. Total order of n. Fine. I'm giving a code to you people. Please verify. And check. Is this working fine or not? Please verify. Is this working fine or not? So, okay, you are moving Nishu. You are moving your head, but after that you can free the space also and you can mark null. Two more things might be you can add. Otherwise, okay, your code is working fine. What about this code? Nishu already know, I know now. He already give the answer. So yes, you people are right. This code is not working. And the reason is already given by Nishu. He's saying that replace this statement with this statement. Next of next. Not equal to null. He want to replace me this statement with this statement, because this statement will take us to the last node. Which node we want to delete? We want to delete this node. Based upon this concept, you will find out 4 to 5 questions in GATE exam. right now this concept will be used actually. Okay, so if you are reaching to the last node, you cannot delete this node. Why? Because I need to store null in the previous node. Now I don't have the address of previous node. I want to store null over here. So I need to stop here itself. To stop at previous node, I need to write next of next. ये ऐसा ही है. मैं दो स्टेप आगे देख रहा हूं. क्या मेरे नेक्स्ट का मैं देख रहा हूं, क्या मेरे नेक्स्ट का नेक्स्ट, यहां से हम देख रहे हैं, यहां पे खड़े होके हम देख रहे हैं कि इसके नेक्स्ट का नेक्स्ट नल है क्या. ये स्टेटमेंट से हम देख रहे हैं, क्योंकि मेरे को तो यहीं पे रुकना है, मेरे को तो यहीं पे रुकना है. मैं अगर यहाँ पे चला गया इस स्टेटमेंट में तो जा रहा हूँ, इस स्टेटमेंट में तो यहाँ पे जा रहा हूँ, यहाँ पे चला गया तो मैं यहाँ पे नल नहीं डाल सकता हूँ, क्योंकि इस नोड का एड्रेस मेरे पास नहीं है. फिर मेरे को दोबारा फिर आना पड़ेगा और यहाँ पे तो रुकना ही पड़ेगा सेकंड लास्ट नोड पे. और यहाँ पे रुकने के लिए मेरे को एक स्टेप पीछे से देखना पड़ेगा. ओके, सेकंड लास्ट नोड से ही देखना पड़ेगा क्या नेक्स्ट ऑफ नेक्स्ट नल है क्या. अगर नल है तो मैं यहीं पे रुक जाता हूँ, लूप को यहीं पे स्टॉप करते हैं और फिर हम क्या करते हैं, ठीक है, उसके बाद इस वाले स्पेस को फ्री कर देते हैं. ये हमने फ्री कर दिया, फाइन. और यहाँ पे नल डाल देते हैं, फाइन, वर्किंग फाइन. दीज टू स्टेटमेंट्स आर वर्किंग फाइन. जस्ट रिप्लेस दिस स्टेटमेंट विद दिस स्टेटमेंट. फाइन, ग्रेट. Okay, so this is the improved one. Simply I replace this statement with this statement. That's it. Okay, fine. I think people got it. I do not need to go in any doubt. If you have any doubt, please mention it again. Okay. Okay, fine. This is the benefit. See, you are trying. If any doubt will come. That's why we are here. We are here to clear our doubt only. If we don't have any doubt, why we are wasting our time here? We can watch any Netflix movie, any series over there. Okay, why we are wasting time with me? I'm not Katrina Kaif. You are spending time with me. Okay, fine. So let's delete. Let's delete at the middle. Let's delete at the middle. So we want to delete a node which is having C data. Can you please write in the chat box? How much time this will take? Time complexity to delete the node from the middle of the single linked list. Almost we are going to finish the linked list. After that, we will solve lots of questions, gate questions and ISRO questions, and you people will solve it. Okay. Sufia is asking something, sir. Tell me, if one paper is qualified with good rank like DA, same benefit like CS. Yes, that will benefit like CS itself. If you have given the data analytics paper, AI paper, get AI paper, if you have given, then you are going to join AI area. AI is one of the booming area. Next decade, I'm a PhD scholar also. I'm pursuing PhD in deep reinforcement learning. I know what is research is going right now. Okay, so that's why I can share this information that I can make one statement that next decade belongs to AI. Next decade, even if you will find out, even small kids, you will find out the keyword AI in kindergarten books also right now in India. In kindergarten books, they are also checking AI. What is AI? So why the government is putting AI in the syllabus of even first class student? You can check out. The reason is that the next decade at least belongs to AI. So if you have filled data science course, okay, if you are giving GATE data science, then you have to choose AI, and the future belongs to that itself. Okay, and if you are giving the GATE CS, okay, might be okay. Now you have two choices with you. You can go to AI also, and you can go to normal BTech. Means no specialization. Specialization you can go in AI, and you have benefit to go to other specialization also, maybe cloud, maybe any other specific specialization you can go to. Okay, so both are giving us benefit. Fine. So we want to delete this, and you people are saying this will take order of n time, and you people are right, because you know that deleting will take constant time. What I need to do, simply put the address of this next node over here. That's it. So how I will do? Very easy. So let me tell you. Okay, let's suppose our ptr is here. First of all, we'll traverse and we will reach up to here. To traverse up to here, that will take order of n time. Or because we are going to middle, you can say specifically order of n by 2 time. 2 is constant, so we can write order of n. Otherwise, after reaching up to here, our pointer reach here. What I need to do? ptr next means I'm talking about this space. In this space, let me store the address of this node, and that will be ptr next of next. That's it. One statement only. So this, now I lost this node. Okay, and this is linked with this. Okay, maybe you can free this node also. That will also not take, that will also take constant time to free this memory from RAM. Okay, fine. Otherwise, this is taking constant time. Just traversing taking order of n time. Okay, so total is taking order of n time. So we know how to delete. That's very easy. One statement, one statement. So I've written a code over here. I have written a code. Let me go through the code. I take a temporary variable, which is pointing to the head node, first node. And until unless I'm not getting C. See, I'm stopping here itself. I'm stopping previous node. I'm not stopping here. My T is not stopping here. My T is stopping here because I need to link this node with this node. So I need to stop here. Yes, with the help of T of next of data, I'm stopping here. So I'm standing here. I'm standing here. I'm watching from here. Is the next data is C or not? Okay, standing at the back, I'm watching. It's like that. Okay, and if that is not C, I will keep moving on. Otherwise, I will stop here itself at this node, and after that, I can just simply, what I'm doing is I'm here. Okay, I'm doing this is same as this thing. One statement. I take a temporary variable and move the I store the, like, okay, let me erase it and write once again. So I take a temporary variable and store the address of this node in this statement. And after this, that I'm linking this node with this node, fine. And after that, I'm freeing this memory. Fine, fine. So this code is fine or not? Yes or no? I just want to know. This code is fine or not? Yes or no? Or you're finding some problem over here? Any, please reply yes or no, yes or no, yes or no. If you're finding any problem, you can say no. But you need to give the reason. Check out. All the people are saying yes, yes, yes. Actually, they are right. This code is not making any problem. And I have make a big tick over here. I cannot write tick if this is not right. Okay, fine. Okay, fine. Let's now talk about this. Is all about the single linked list. We done all the operation, traversing, deleting at starting, middle, end, insertion at starting, middle, end. Okay, and now let's talk about, this is a structure of circular linked list. Okay, last node is attached with the first node. That's it. Okay, there is a one pointer only which is pointing to the first node. Otherwise, last node is don't have null. That is having the address of first node. That's it. This is circular linked list. And let's talk about the structure of doubly linked list. In doubly linked list, one node is having this structure, having data, address of previous node, address of next node. So here these are pointers. Okay, these are storing the address. This is storing the address of previous node. This is storing the address of next node. Data is one only. We are storing one data over here. Okay, so here unlike single linked list, here we can move backside also. We can move from this node to this node, this node to this node also, this node to this node. In single linked list we can move from this to this to this to this, but we cannot come back. But here, because we have the address, we preserve the address of previous node also here, so we can move back, we can move back also, we can move back also, we can move back also. Okay, one more thing we can add over here is that here in the first node we have null, here in the last node we have null over here. Okay, fine, this thing is also there. So this is the structure, that's it. This is the structure of the doubly linked list. Fine, very easy. Now it's practice time. We will solve gate practice questions. We will solve ISRO questions. Actually, you people will solve now. It's your turn now. Okay, I have done from my side. So doubly linked list, Kunal we use whenever we need to access. See, you need an application in which you want to go back also. You want to access immediately previous data. If you want to access previous data in order of one time, this is the requirement for your software. Okay, you want to access the previous data in order of one time, then you will use the doubly linked list. If you don't need to use the previous data, then why you are wasting the space by taking the node structure like that? Okay, and that will take more space. Why are wasting if you don't need in your software? So if your software need that, your application need specific this thing, your program need specific this thing, you need to access previous data, you will use doubly linked list. Fine, okay. Now let's jump to the real problems. These are not my problems. These are not my problems. Let's see if you people can solve these problems now. Keep trying, keep replying, doesn't matter right or wrong. Keep trying, keep replying. Let's check out. Let me tell you, the moment you will be able to solve even a single question yourself, you will get confidence. Your confidence will boost up. If I will try, that will not that much help you. This is the truth. Let me tell you, 20%. You will learn only 20% if I will explain this question. If you will try yourself, you will learn 100%. You will learn 100%. So this is the difference. If I will try, 20%. If you will try, doesn't matter you are getting answer or right or wrong. Doesn't matter you are right answer you are getting, wrong answer you are getting. Doesn't matter. Learning will happen 100%. Please try. Please try. Or let me tell you one more thing. There is no way. If you are not attempting PYQs, nobody can bring you below 1000 rank. And this is not my statement. I'm not ready to take any blame. This is what happening from last 10 years. This is the data from last 10 years. So please try. Please try and reply. This is very important to solve this question yourself. Please try. I'm waiting for your answer. Right or wrong doesn't matter. Right or wrong doesn't matter. Please reply. Let's connect with each other. Many people are replying C. Some is replying A also. That's great. Keep checking, okay? You can ask the time for. You can say wait if you want some time from me. Because we have limited time, so accordingly I'm moving little bit. But trying that, I do not leave any doubt in your mind. Still okay. Everybody, most of the people are saying C. Let's see what is the right answer. C is the right answer. Let's go with the majority. Okay, fine. It's okay. If you are trying, that's great. That is the moment you try, learning happens. No need to worry. Fine. Okay. So let's see what is happening. Simply we creating a node over here. and we store the address of that node in P. Fine. And in that node, okay, we created a node in this statement. Fine. And in this node, we are storing value 10, informant data. We are storing 10. It's a pseudocode. Okay. And the next part of this, we are storing we are storing the list. So we have a list with us, linked list. Okay. So linked list is like this. We are storing the address of list. So list is just like a head to this list. Okay, this is storing, let's suppose, starting address 1000. So we stored 1000 over here after executing this. So this get linked with this, and then in last statement we are putting list equal to P. So list is now pointing here. What we have done, we know we inserted a new node at the starting of the linked list. So let's see. People are saying C, inserting a node. Yes, we are inserting a node. We are not popping anything from the stack. We are not removing any node. We are inserting. We are not modifying existing one. We are inserting a new node. We are inserting a new node. Okay, fine, fine. So great. Maximum people are giving the right answer. Can you tell me what is the function of this given code? Check out this code and please reply. Please verify and reply. What is what this code is doing? What is the function of this code? निशु इज आस्किंग PYQ से 500 के अंडर आ जाएगा क्या रैंक? 500 के अंडर रैंक आ जाएगा क्या PYQ से? Might be, but if you want surety from me, then you need to go with the test series. You need to go with the test series. Then I can give you surety. If you are giving 2 test series, I can give you surety. It's not about just giving the test series also. Let me add one more thing. Give the test, analyze it. Give the next test, analyze it. Where you are making mistake. Check out where you are making mistake. Give the next test, analyze it. If you will get, giving you surety right now, you will get below 300 rank. You are asking for 500, you will get 300. Confirm. Again, this is not my statement. This is what is happening every year. I'm sharing that thing only. Confirm. Confirm. Okay, so the people are saying we are reversing the linked list. Let's see. Oh, this question is asked in so many product-based companies also. And this is a gate question actually. They are stealing the gate questions only. Okay. So, yes, you people are right. We are reversing the singly linked list. Yes, we are reversing the singly linked list. Let me give you just idea about it. Okay. How this is working, you can check out yourself. I'm telling you what this code is doing. We have 3 pointer here. One is head, one is previous, one is next pointer. It's working like this. Like previous is pointing here, head is pointing here, and next of head is pointing here. Next of head is pointing here. Okay. What we are doing here, we are just see what we are doing. Look at here these statements. In the head of next, we are storing the address of previous. Head of next is this area. Head is this, head of next is this area. I'm executing this statement. We are storing the address of previous. Address of previous is 4800. So we store 4800 here. Moment we store 4800 here, actually this link is lost, and this node is get connected with this node. Okay, fine. And when we execute this node, this statement, now after linking this node with this node, next node with the previous node, we are now moving our previous comes here. Previous becomes the head, previous comes here. Fine. And after executing this node, head become this, head become this node is now pointed by head. Okay, head is no more this. Okay, previous is not more this, previous is new, previous is this, new head is this. And if you will execute in the loop, you will come back, you will execute this statement, you will see that okay, next of head will be this, next of head pointer is pointing to this node. Okay, now see, we just move previous head and next of head, 3 pointers, one step. Again we are doing the same thing. Let me do again same thing. So head of next, which is this area, in this area I'm storing the address of previous node. Previous node address is 4900. So this link will be lost and this link will be generated, new link. Okay, and after executing this statement, now again after making this link, we are making this link again, we will move previous here, head here, and next of head will be actually null. Now that there is no more, no further node is there. Okay, again we will link it to this, we will keep doing this thing, we are doing this thing actually in this. Okay, so you can see here we are breaking the previous link, we are linking the next node with the previous one, previous one, previous one. So this is reversing our linked list. Our new head will be here, our new head will be here. Go through this code for more clarity, otherwise this is what this is doing, I just tell you. Okay, okay, fine, you can go through it step by step yourself later on, can take the snapshot. Fine, can you please answer this question? This is similar to previous one also. These people, I already tell you, these people are taking the question from gate itself, and the reason is that you are going to IIT first. You people are going to IIT. From IIT you are landing in these product based companies in Google, Amazon here, and now you are taking the interview. When you are taking the interview, you have the knowledge of these concepts, you are asking can you implement this thing, you are asking like this, can you implement this question, because you know the logic. Gate will tell you the logic. Okay, after that you need to just practice on particular language. Okay, so that gate can also help you means prepare for the product based company, because you are preparing DSA is asked in all the product based company, most of them. Okay, and here at least, which is the most important part, is logic building, that is very much done in gate. Okay, so this will also help you, preparing DSA here will also help you to prepare for the product based company. You will use these notes, make your notes, you will use these notes in IIT also when you will appear for the company's exam. Can you answer this question please? Can you please answer this question? Waiting for your reply, more people. Sufia is saying A, Kunal is saying A, Nishu is saying A. You can ask me to wait if you think that I'm moving a little faster. Mr. Verma is also here now, new candidate, new player is with us now. He is also in the ground to play. That's great. So let me check out what this problem is. Consider the problem of reversing the linked list. Okay. For to take an example given flow, okay, they provide us a linked list. Fine. We need to reverse it. So this is the reverse form. Okay. Means see is now this is our head, E is our head, and E is pointing to D, D to C, C to B, B to A. Okay, and A, in the A we store null. That's it. क्या पूछ रहे हैं देखते हैं यहाँ पर. Which of the following statement is true? Which of the following statement is true about the time complexity? Okay, about the time complexity of the algorithm that solve the problem in constant space. So we want to convert, we want to reverse the linked list. How much time this will take? Because the answer is here itself. How much time this will take? See how much time this loop will execute. You're moving your head from starting till you're not reached to the null, till you not reach to the null. So you're moving from every one by one to all the nodes. Okay, and you are executing 4 statements every time. This loop is executing actually going through all the nodes. If number of nodes are n, so this loop is executing n time. And you can say okay, 4 statements are you are executing 4 into n time this will take. that is actually order of n time. So reversing the linked list, we can say will take order of n time, order of n time. Okay. So here we can relate. So A is the right answer. One more thing I can add over here is that, see, they are using theta right now. They are using theta. Uh, this will be better, means why? Because in the best case, uh, minimum time to solve this problem is theta. Okay. Okay, and maximum is also, because this algorithm is taking both. In this algorithm, minimum time is also n, and minimum time, okay, represent with big omega, and maximum time is also n. So it's better to represent with theta. Okay, but I'm not going, because they have mentioned worst case. So actually, if they have mentioned this thing, so actually this also doesn't make impact. Okay, so I'm not going in that detail, but okay, fine, at least we can represent theta over here. So, and you know this is n time is taking. Fine, okay. Try this one. This question is asked in lots of product-based companies also, but in the form of coding. Okay, can you answer the question of this problem? Can you answer it? Can you solve it? Keep trying. Keep trying. Rishikesh, about what you are asking, how means, uh, so meanwhile I can answer your question, meanwhile the other people are solving it if you want. If how order of n? So that we have already discussed, means the loop is executing order of n time. Head is moving to the till the null. Okay. So one by one step that is going through all the nodes. Nodes are n. So that will take order of n time. Nishu, I think already given the answer. Yeah. That's great. You people are helping to each other. That's really great. And that's the benefit to join the class also. Actually, in class, what the benefit of the class? If you will study in class, then sometimes we don't ask the, as a student, we, this remains the tendency that we don't ask the question from the teacher. Might be, I don't know. There can be many reasons. Might be we feeling that this is very silly question, although every question is very important. I don't know why we feel like that. Okay, this question should not be asked, might feel low. But in class, what is the benefit? We can easily ask to our friends. Friends are very important. We can ask them anything, okay, easily, and they can answer exactly. They can understand from what point of view you are asking. Okay, so learning in group is very important. You can make your groups. Okay, makes your group, learn in always in group. That will keep you motivated also. This is a long way to go. Let me tell you, GATE is not a 1 month exam. That takes many months, 6 to 12 months, let me tell you. And to continuously studying for 6 to 12 months, actually, if this will be great if you will be having a group. If you have a group, then if you're maybe not feeling, not want to study, if you will see your friends, they are studying, you will also go and study. That they will keep you people will keep you motivated, and you can answer each other questions also. So the journey will become actually easy if you will move in the group. Okay, let's come back to the question. Rishikesh, let me tell you one thing more. You are sharing these things openly, that's great. And this is, let me tell you, this is the problem with toppers also. Toppers also make the mistake. The toppers means who are getting below 100 rank. Those people are also making this mistake. They are not reading the problem statement properly. And what they are doing to improve it, they are getting below 100 because they are handling this problem means not reading the problem statement properly. This is the problem with everyone, let me tell you, as a human being. So what those people are doing specifically who are getting below 100 rank, they are marking those question particularly where they are making this type of mistake, like not reading the problem statement properly, and they are again coming to those questions and solving it. So when they come to back to those type of questions again and again, then the chances goes reduce to make the mistake in gate exam. Okay, thanks for sharing it. This will help other people also. Fine. Okay, so can you, so let me go through the question right now. You are given a pointer. Okay, we are given a pointer, a reference to the node. So this is the pointer we are given to a node which we want to delete. Okay, we want to delete this node in a linked list of n nodes. So total number of nodes in the linked list is n. Fine. The task is to delete the node. Okay, we want to delete this node. The pointer reference to the head is not given. So head is not given to us. Head is not given to us. We don't have the starting address of this linked list. Okay, so can you delete this node? First of all, yes or no? People are saying yes. And if yes, then what is the logic? How you can delete it? How you can delete it? Can you tell me the logic? How you can delete this node? Can you tell me the logic? If you're writing yes, then yes, we can delete it. We don't have head pointer. We have only this node. What we need to do to delete this node? We need to attach this node to this node. Okay, we need to attach this node to this node. Okay, but this is a singly linked list. I cannot access this node address. I don't have head also. I don't have head also. But yes, we can do. And it's a good question actually. And that's why this is asked in lots of product based companies, because this is a good question actually. This requires reasoning. Think over it and reply. Rajveer, lengthy questions you will find out in computer network and some from CN. Okay, DBMS also. Okay, these are the main subjects where you will find out. Okay, let me tell you one thing. This remains the problem. This is the from last papers. I'm just giving you one intuition that if the question is lengthy, the question is easy. If the question is lengthy, the question is easy. You just need to understand everything logically. Okay, so how to face that? Now the question, first thing comes, if you are not preparing, if you are not solving those questions in advance, if you are not solving pyqs, lengthy questions earlier, in the if you are solving directly in gate exam, you will get feared. You will not attempt the question, that is sure. You will think that this is so much lengthy question, you should not try. But if you have tried it earlier, you will find out that these questions are easier than other questions. These questions are easier. If you are able to understand the question, you can answer the question. If you are able to understand the question, you can answer the question. These are straightforward questions. They don't have empty. They don't have empty part in that. Other small questions have empty part. Okay, this is like empty exam actually. It's not about only engineering concepts. You need to not engineering knowledge, but you need to use the reasoning. Apti, your apti also. Okay, so long question do not require apti. They require to, are you understanding the question properly? This can be done by practice. If you are solving pyqs, okay, then you will feel confident. Okay, I can attempt. I'm sure I will attempt this question easily. And CN is a subject, let me tell you, where if you understand the logic, and at Geeks for Geeks, I prepared particularly this subject myself, computer network. You will find out my videos, near about 20 to 25 videos from my course on YouTube free. Go through the videos, and after going through the videos, you will be able to attempt the gate questions. People feel afraid, I see, from computer network, I don't know. And the reason is that they are not understanding the concept. If they understand the concept, we human beings are very good at logical thinking rather than cramming. We can even your vice chancellor of your college, of your university, cannot remember the things for a long time. He is also human being. Okay, nobody can remember. We are human being. What we can do, we can logically think over it and we can come to answer. Computer network, if you will logically understand, then these lengthy questions you will find out. You will start feeling like that. These are the question where 100% you will get the marks. 101% because no apti is there, no tricks are there. Okay, in other questions you will find out the tricks. You need to verify. If you are finding the answer in the first attempt, there is something fishy is going on. In the gate exam, keep this thing in mind. The moment you are finding the answer, something fishy is there. Check out other option also. Check out other options also. Lengthy question, these things do not happen. Practice, please practice. Okay, so I'm coming to this now. Previous node का address कैसे आएगा? Nishu is asking. Yes, I'm asking the same thing. कैसे आएगा आप बताओ? Previous node का address कैसे मिलेगा अपने को? यही तो मैं पूछ रहा हूँ. यही तो ये कंपनी पूछ रही है आपको. यही तो पूछ रही है. Otherwise, this is a 4-line code. This is a 3 to 4-line code. Okay, so let me tell you. You think over it. That is great thing. Okay, let me tell you. What you can do is here is what you can do is see what we can do. We have the address of this node. Fine, we have the address of this node. We want to delete this node. What we can do, see, I can access this node. Yes, I can access any node further actually. After this node, I cannot access this node and this node. Confirm, I cannot access. I don't have head also. I have the address of this node. What I can do, I can copy this data over here. I can copy this data over here. Then I can delete this node. Yes, I can delete this node. I just need to attach this node with the next node. I have the address of this node. I delete this node. I delete this node. Copy the data, overwrite over it. Now, that's it. Deleting a node. Deleting a node. What do you mean by deleting a node? Deleting a node means deleting the data. Deleting the node means deleting the data. Here, all the nodes have the same structure. The previous node, the next node, all the nodes have the same structure. Why we are using this data structure? To store the data. Deleting the node means we are deleting the data. We deleted the data. We just copy this data. We use the trick that, okay, let's copy the data to this node. And now we can attach this node to the next node easily. How? Just simply del of, let's suppose this is pointed by del of next is equal to del of next of next. Next of next. That's it. And you can free this space also if you want. You can free first del of next. You can free that. Okay. After that, okay, you can store it in temporary variable and you can free. You can free it. Fine. Are you able to understand what I'm trying to say? Simply copy the data from here to here and now we can delete it. And how much time this is taking? Order of 1. Why these people were very interested in this question is, whenever they see order of 1, they can solve the complex problem in order of 1 time. They jump to those type of problem. They love to ask the question from there. Okay. Okay, I'm sharing the code also. We do not have the last pointer to traverse it from the last. No, yes, Rajveer, we don't have. We don't have the head pointer. Yes. So I hope you find out this thing. This thing, okay. Nishu is saying this thing is not the right thing to do. See, we need to delete the data. Okay, it's not about the moral practice. We are here. Okay, we need to implement the code and we need to perform the task. Okay, so we just need to maintain the data. Okay, so we can maintain our data. Okay, in here and we can delete it. So what we are doing simply here, we are okay taking the address of this node del next in a temporary pointer t, fine. And after that, okay, we are shifting the data. We are taking the data from here and copying it here in this statement, fine. And after that, uh, we are just connecting this with the next of this here, and after that we are deleting, freeing this space here. That's it. That's it. Okay, fine. Let's solve the question related to this itself. Can you answer this question? Check out this and try to answer this. Yes, Kunal, we don't have the last pointer also. That's why we cannot traverse. And this is a singly linked list itself, first of all. Even you have the last pointer, you cannot do anything. Check out this one. Keep trying, keep replying. Let's come to back to our mantra. Keep trying, keep replying. Keep trying, keep replying. And if you have not give a thumbs up till now, please give it first. And please, okay, everybody, please write in the chat box, okay, how the session is going on. Please something write in the chat box also right now itself. And that will help me a lot. And I will come with more energy and more enthusiasm and more information with you people. I will come in the front of you people. If that is the motivation actually, if you're writing in the comment section also, please if you take some time and please write in the comment section also how you're finding this session, if really finding helpful, please. So can you, Rishikesh, not here in the chat box, in the comment section, not here in the comment section, if you can write, please. Okay, fine, fine, okay. So people are still saying order of n. Traverse करना पड़ेगा. Okay, let me read the problem statement. P is a singly linked list. P be a singly linked list. Okay. Q is the pointer to the intermediate node. Okay. So this is our singly linked list we have with us. And P is pointing here. And Q is a pointer which is pointing to intermediate node X in the list. Okay. What is the worst case time complexity of the best known algorithm to delete the node X from the list? So, see, if we, let me tell you, the answer can be, there can be two answers over here. How you are taking this question? One answer can be order of 1 and one answer can be order of n. Okay, let me come to the answer 1 first. Let me come to the answer 1 first. Okay, fine. Yes, Kunal, I'm coming to that. So why the answer can be order of 1? They're asking us to, they give us a pointer. Okay, they give us a pointer to a intermediate node. We want to delete that node. So you know that how to delete the intermediate node now from the previous question itself. You just need to execute 4 statements that will take constant time. You do not need head itself. You do not need to traverse here. What you need to do, you will copy the data from here to here. You will copy it and you will link this to the next. You will link to this to the next. So if you are using this procedure, this will take order of n time to execute. Okay, this will take order of n time to execute. Okay, fine. This is the same method what I discussed in the previous question. Okay, fine. Second thing, what can happen? Actually, if you will find on internet and they have given it order of n. Okay, and on GeeksforGeeks website even you will find out they will give in this order of n, and the reason they are given is that, okay, might be they are saying that your q q is pointing to the last node. Q is pointing to the last node. Okay, if q is pointing to the last node, this is our last node, then I cannot apply the previous method. Then we cannot apply the previous method. In previous method we were taking the data from the next node, copying it here and deleting that node. But here I do not have any other node next, so I cannot delete the next node. And now in this case, what I need to do, if I want to delete this node, I need to put data over, I need to put null over here. To put null here, this is a singly linked list. I need to traverse up to here. If I'm traversing up to here, I will take order of n time. If I'm traversing up to here, that will take order of n time. So what I want to say is that if we need to delete the last node, if we need to delete, then confirm that will take order of n time. That will take order of n time. Why? Because now the previous method I cannot apply because I do not have further any node. I cannot copy the data and link it to the next. That method cannot be applied. Okay. And if that method cannot be applied, I need to traverse. Here they have provided the starting address of the linked list, and here we can move, okay, up to here, okay, up to the second last node and put the null. So for that, traversing order of n time is required. So only one case is there. If we are at the last node, then that will take order of n time. That will take order of n time. Okay. So in that case, because they're using the word worst case, So in the worst case, the node can be here also. The queue can be here also at the last. So that's why the time complexity can reach to order of n. Okay, but there can be one argument over here. There can be that, okay, they are using the word intermediate also. They're using a word intermediate also. They are not saying the last one. Intermediate is not the last. Intermediate should not be considered as the last node. So this cannot be the last node. This delete node which we want to delete, which is pointed by x, that cannot be last node because they have used the word intermediate. Intermediate is not used for the last. Okay, you can say that, okay, that may not be the first one, but that should not be the last one. So that will be somewhere in the middle. So if that is the middle node, if anywhere we want to delete, then that will always take order of one time because of first method. Okay, that will take order of one time. So however you are taking this question, you can take it on internet. You will find out order of n. They are saying that, okay, that can be the last node. So in last node we cannot apply the previous method, so that will take order of n time. But you can argument like this also, that, okay, that can be intermediate node also. They have mentioned intermediate node. So because this is intermediate node, so I can delete it in order of one time. Okay, although these type of questions might be that some problems can come in the gate question itself. This is happening in the previous years, and they give full marks if there remains like this type of problems remains there, where there can be two possible solution. They give the marks to this person also and this person also. Okay, but we can put anyway, you can take it like okay, so you can take it anyway, like order of 1 or order of n. I have given both reasoning to you. Okay, more correct from this point of view looks like order of 1. Okay, because intermediate word they have used. Okay, but on internet, Geeks also and other websites also, you will check out, they have mentioned order of n. So I just also, okay, write order of n. But I am personally saying that, okay, according to me, I'm making statement that this should be order of 1. And I give you the reason, because they are giving intermediate. They are using the word intermediate. Fine, okay. You can check out it. And yes, Chinmay, ambiguity exists. Fine, okay. Let's move to the next question, and this is GATE 2020. Check out this one. Keep trying, keep replying. Let's keep this mantra Next answer I want from Chinmay itself. Chinmay is new candidate here. Please reply to each and every question. Right or wrong doesn't matter at all. In class, that should not matter. Please reply. Please try. Please try. Oh, we are getting answer from Chinmay. Very fast. Rajbir, actually, again, okay, I will say that again, this is ambiguous question. This is ambiguous question. They have not tell us actually. In this particular question, I will say that I cannot comment here itself. This is 100% they are ambiguity is there, 101%. They are asking us to sort the linked list. They are providing n elements to insert, an element to insert in an empty linked list, and they want the sorted linked list. Okay, sorted linked list. So if they want sorted linked list, just this thing, sorted linked list at the end, then what we can do, we can take these n elements, insert them into an array, apply any sorting algorithm, might be quick sort. Okay, sort them. The elements will be sorted now. Elements will be sorted. How much time this will take if you apply quick sort or maybe merge sort? So that will take order of n log n time to sort the elements. After elements get sorted, now we can create the linked list. We can create the linked list. So creating the linked list will take order of n time. Inserting one node insertion, order of 1 time, n node insertion, order of n time. So if just we are providing the sorted list, if they want sorted list from us, we can do that. How we can do that? Take the elements, store them in an array, and sort them using merge sort and quick sort. Okay, and this will take n log n time, time to sort the elements. Okay, n plus to create the linked list, order of n time. Total time n log n. Total time n log n. So this is one way you can take this question. Another thing, you can read this question like that. You can say that linked list need to be maintained. Linked list need to be maintained in sorted order. Maybe you can take the point that, okay, every time you are inserting an element in the linked list, means you need to take the elements and you are inserting directly in the linked list. You are directly inserting them into the linked list at every moment of time. You are maintaining is to be sorted. Okay, so in that case, if you are inserting one element in the linked list, okay, then and sorting it is inserting it in sorted manner. Actually, it's like insertion sort you are doing now. Okay, so inserting it in sorted manner, then this will take order of n square time. It will be working just somehow like insertion sort, which will take order of n square time. Okay, means every time one element you are taking, insert it in the list wherever that should go. That should go fourth location because that is smaller than the sixth and greater than the fourth one. Okay, that next element should go at the end. Next element should go at the first position. Next element will go at the third position. So order of n time you will take for every, in the worst case, order of n. Okay, and total time will be n square. Okay, n into n square. So these again two solutions are there. Okay, and again, so I write, okay, B or C can be the answer. B or C can be the answer, whatever way you can take it. Okay, so Do not need to worry. I just shared this question. I don't want to create any doubt in you people mind. This happens very rarely. Okay. And do not need to worry. Just I'm sharing this because I'm just showing that okay, it's okay that is happening. Do not need to worry, okay, about this thing. Okay, they are providing the marks. If some ambiguity comes in the question, they give the marks to actually uh, to all the people actually. Okay, do not need to worry. This happens. These people are also human beings. Okay, fine. Now onward, you will not find out any ambiguous question. Let's move on. Can you solve this one? Gate 2003. Keep trying, keep replying. जिनमें वो एन स्क्वेयर दैट विल नॉट बी उसने उन्होंने वर्स्ट केस पूछा है तो वर्स्ट केस में आप ये लॉजिक दे सकते हो अगर आप मेरे से बोल रहे हो क्या आप मैं आपको एन एलिमेंट्स दे रहा हूं आप मेरे को ये स्टेटमेंट बोल रहे हो मैं आपको एन एलिमेंट्स दे रहा हूं ओके आप मेरे को एक सॉर्टेड लिंक लिस्ट दे सकते हो मैं बोलूंगा हाँ वर्स्ट केस में मैं एक मेरा एल्गोरिथम जो है ना वो वर्स्ट केस में एन log n टाइम लेगा वर्स्ट केस में मेरा एल्गोरिथम जो पहले वाला मैंने आपको बताया ना वर्स्ट केस में एन log n टाइम लेगा तो मैं वो मैंने अपने एल्गोरिथम के लिए बोला है मैं जो मेरे एल्गोरिथम की बात है और वो एन वर्स्ट केस में एन log n टाइम ही काउंट होगा ये वन ऑफ द बेस्ट एल्गोरिथम है और ये वन ऑफ द बेस्ट एल्गोरिथम है जो वर्स्ट केस में एन log n टाइम ले रहा है मैं दूसरे लॉजिक भी बता सकता हूँ जो एन स्क्वेयर टाइम ले रहे हैं और मे बी एन क्यूब टाइम ले रहे हैं अगर मैं बिल्कुल ही वर्स्ट बिहेव करना चाहता हूँ तो आई कैन प्ले लाइक अ किड and I can write an algorithm which is taking n square time more than that but अगर आप इतना ही चाहते हो मेरे से कि मैं आपको n नंबर्स दूं और आप मेरे को एक सॉर्टेड लिस्ट बना के दे दो तो वो मैं वर्स्ट केस में ऐसा एल्गोरिथम दूंगा आपको वर्स्ट केस में n log n टाइम में करके दे देगा तो ठीक है वर्स्ट केस में कितना टाइम लग रहा है n log n according to first algorithm which I shared okay fine please try this one Rajveer I think that is clear what I'm talking about. Okay, the people are replying the answer from here. That's great. Right or wrong doesn't matter. Keep replying. Let's write in the chat box. You can write I don't know. I don't want to give answer. You can write that also. Whatever is coming to your mind, you can write over here. You can do the same thing in your BTech class also. Whenever the professor asks you what is the answer, you can say, you can speak anything else. You can start singing the song. You can say that this is what coming to my mind. And Puneet sir have told me, just speak whatever is coming to your mind. And you can check out on the YouTube, on Geeks4Geeks YouTube channel. You can say this is not my fault. Please reply. Please reply. Keep trying, keep replying. Keep trying, keep replying. Let me also go through a little bit about what this is doing. Here, this is the structure of the node. So here we are creating a node. This is structure of the node where we have data and we have next part of a node. Okay, and we have a pointer which is pointed to a linked list. Okay, p is pointing to a linked list. If p is null, that means linked list is empty. We already know these two statements. We have discussed. If this is the statement, that means there is one node. There is one node in the linked list. Okay, and what this statement is doing, we are updating the data. We are updating the data part. Okay. Okay, we are checking. We are not updating. We are checking. This is the comparison condition. If this If they okay, this is our linked list. Let me create the linked list also now. So this is our linked list pointed by P. This is the last node. Fine. We are saying that data of this is this less than or equal to data of next node. So this is pointing to the next node. This is pointing to this node. So this is checking data here, means data 2 is this greater than data 1, greater than equal to data 1. Data 2 is greater than equal to data 1. Here this is what we are checking. Let's suppose here we have 10, here we have 20. If this is like this, then yes, this condition is true. One more condition we are checking, this and. Okay, we are calling this f function recursively. This is a recursion going on over here. So we are calling this function recursively, fine. And we are passing, if this is happening, 20 is greater than 10, then uh, what we are doing is, uh, and this condition is also happening. Okay, what this condition is doing, this is just calling the function. Okay, then we are going to next, we are passing this as a p, and this will be our p of next. This will be our p of next. Okay, this will be our new p, because p of next will be passed here in place of p. So this will be our p. Again we will check, is this 20 is smaller than 30? Again we will check, is this 30 is smaller than 40? We will keep checking like this. Okay, we are keep checking like this, and okay, and until unless we do not reach to the last node, until unless we do not reach to the last node. Okay, so the answer you people are giving is right actually, and you are saying, most of the people are saying answer is B. And let's see, let's check out the answer first. We need to check in this given linked list P, what is the function of this f, what is the function of, what function returns, what function returns. The elements in the linked list are, this is checking, this linked list is, this function is checking if the element in the list are sorted in non-decreasing order or not. So this is non-decreasing order. 10 is either greater than equal to 20, is greater than equal to, maybe 20 can also be here, greater than equal to 30, and greater than equal to 40, like this. So this is non-decreasing order. In non-decreasing order, element can be equal also. Okay, so if this is the case, like this is checking this thing actually. How we are checking recursively? How we are checking recursively? We are checking this condition again and again. We are checking this condition again and again actually. Okay, and might be, so yes, this statement is right. Might be some people can say is also right. Is also right, because if the list is empty, this is also checking if the list is empty, then or uh, this is also checking if that is having exactly one node. Okay, but this is actually in entirety, this is not checking only this is not checking only this is also checking this, but this is checking this thing also, this is checking this thing also. Okay, so this is the correct answer. B is the correct answer. Yeah, A is not fully complete. Yes, Nishu. किसको भूख लगा है यहाँ पर? Okay, so B is the right answer. Let's move on. ISRO 2008. So ISRO is going to launch Chandrayaan 4 now. If you want to be part of that mission, you need to solve this question. If you want to be part of Chandrayaan 4 mission, you need to give the answer of this question. Please try. This is very easy. ISRO questions are very easy. ISRO questions, if you compare with the GATE, they are very, very easy. If you can crack GATE, confirm you can go to ISRO. Their question set, you can see them. They are providing these questions. In 2008, they provide this question. C is the right answer, yes. We know that in a doubly linked list, we have three fields also itself. Okay, why they are using minimum, even maximum also three. Okay. Maybe maximum why they are not talking about maximum, maybe okay they are considering, okay, yes they can consider. This can also be a doubly linked list. Maybe data is here, here, here. There are three data, but the link will be, this will be two. Okay, so that's why they specifically mentioned minimum. Yes, okay. So minimum number of cells in a node of a double linked list will be three. Yes, you people are right. Fine, easy question. Try this one. 2021. 2021. Try please. Please mention Imran this thing in the comment section. Then our managers will see that and I can show them. Check out these students are asking for the playlist on stack and tree and hashing. Then I can say them I need to deliver that. People are asking and many people are asking. So if you will, people will write these things in the comment. Comment means proper comment section. Then this will be easy to say to my manager that okay, I need to deliver, students are asking. I can then easily convey this to message to them. Otherwise these people don't believe their managers. Okay, they must be listening. They will catch me after this session. Okay. Okay, try please. Connect, you people can connect me on LinkedIn if you want to connect. Try this question. Should I try? Little looking lengthy, but not that much tough actually. So let me try. Okay, let me try at my end. You please check out here. We don't have time, so let's solve more questions and uh, let me try this. You please help me to solve this. But okay, okay. So this is the node structure. Okay, we have a node structure. Let me make it over here, which have a value, and this is the next part. Fine, okay, and we created different pointers of this, which can store the address of this type of node. Okay, we create two pointers. Fine, and no, three pointers. One is box E, box N, and head. One variable also we have which is storing a value 0. Fine, we create a node. This is creating a node. This statement is creating a node in C language. Okay, reserving the space in memory. We already discussed this thing. And okay, let me create a node over here. Let's see what this is doing and let me keep moving according to that. This new node is created and this is pointed by two pointers actually. One is box E and one is head. So let's do it box E and also by the head actually. So let me write here head. Okay, now we are storing the value in the value part of this node. What is the index value? 0. So we are storing 0 by this statement. So let's store 0. Fine. Now let's execute this loop. So this loop is starting from 1 to 3. 3 times this will execute. Fine. We are making a new node. Reserving a space for new node means creating a new node. So let me create a new node. Fine. This statement is executed, and in the next of this new node, box E is this, the next of this is this. We store the address of new node. New node is box N. Okay, next. N for next. Okay, E for earlier, maybe you can see E for earlier. Okay, fine. So with this statement, I'm linking this node to this node. That's it. Fine. And in the next, we are storing the index value. Index value in the starting is 1. Okay, so we store 1 over here. Fine. And now box is here. We shift box this variable here. See, we are not moving head, otherwise we will lose our linked list. So box is just working as a temporary variable. Now we again go back to the loop. Now I value is 2. So actually what we are doing is we are creating 3 more nodes over here in this loop. In this loop, we are creating 3 nodes and storing 1, 2, 3 index value, which is incrementing 1, 2, 3. Okay, and after that we will come out of this loop. That's it. Okay, fine. So we done this thing now. We done this thing. Let's see what this loop is doing. This loop is moving 4 times, 0 to 3. Okay, let me do it. Let's suppose I'm writing over here for index value 0. First of all, let's move this loop for index value 0. Let me execute. This is printing actually this data. What data? uh, this is printing 2 data. One is this data, one is this. Index value is how much? 0. Okay, let me write here 0. This will print another value, head of value. Head is here, so this will print this value 0. So this will print 0 0. After that, head will move to the next. Okay, so let's me move head to the next. Fine. And we will print index plus 1. Okay, again in the same for this first time we are executing, we print index plus 1, 0 plus 1, 1. Okay, index value is 0, so we print 0 plus 1. So here head is now here, we printing 1, 1 1 we print. Okay, so for index 0 we print this thing. For index 1, let's see now. Index 1, we are executing the loop, this loop. Okay, so what we are doing here is actually we are printing 2 value here, we are printing 2 value here. So right now index value is 1, we print 1 here, and head is at also at 1, we print 1. Fine. And here we are moving our head also. Here we are moving our head, repeating the same thing. Now head is not more here. And we are printing index plus 1, that is 1 plus 1 2, and index head value is also 2. Head value is also 2. For index, now in the loop I'm executing for 2. If index is at 2, what we are doing, index value, that is 2, and head value is also 2. Then move the head, and again printing index plus 1, that is 3. Printing head value is also 3. Last time, okay, let me write here index 3 for 3 index. Again come to the loop, index value is 3. Head value uh, uh, head value is also 3. Okay, head value is also 3. Fine. Now we move the head head will create the error over here. Actually, head, there is nothing here. We do not store even null here. We do not store even null over here in the last node. You can see here there is no null over here. So head is pointing now to a address. This is a just any random garbage value. Head is now pointing to some garbage value. When pointer will point to any any address which is not defined, okay, that will create the runtime error. That will generate the runtime error. Here also this will generate the runtime error, because now head, whenever you will execute this statement now, okay, and even after that, if you will execute this statement, when let's suppose head is now having any garbage value, garbage value. Then you are accessing the value in the garbage value. Again, that is creating the problem. So this thing is known as you're dereferencing an uninitialized pointer. You're finding the value. You are the finding the value. Uh, you're trying to find a value in an area which is not initialized. Okay, okay. So you're trying to dereference that value. So this will create a runtime error. Okay, this will create a runtime error. So D is the right answer, and that is already given by Rajveer itself, and Nishu I think also. That's a great idea, Sufia. If you are doing private job, if you are in service-based company, and it's good idea to go for the gate, because these people will not increase your salary, and after 5 year, you will be having more responsibility on you, but your salary will not increase as your responsibility will increase. You might get married, and then this will increase the responsibility. The salary must be high. So either you need to prepare the DSA to shift to product based company. Only they can provide you the good salary. Service based company will not provide you good salary in software development role. And after 10 years, this will be, you will quit your job if you will remain in the service base. If you are not increasing the profile, maybe management, if we are moving on, then other thing. Otherwise, as a software developer, the increments, living in Bangalore, NCR is very expensive. Okay, and with family, with kids, really, after 10 years, so it's a good idea. What I want to say, yes, it's a good idea to invest 1 year to change your life. Fine, okay, let's move on. What about this question? ISRO 2008. Try this one. Keep trying, please. Keep trying, keep replying. Keep trying, keep replying. What is the answer over here? Please reply. This is not that much tough question. It's okay. Whatever is coming to your mind, you should reply that. So these, don't worry. Yes, these questions have standard. Means these are from GATE and ISRO. So, but you will feel confident if you are trying yourself. Okay. So let me see. Some people are replying C and D. Some people are replying B, D. This time, most of the people are giving different answers. Yeah, we need to check out this one. Okay, fine. Which of the following operation is performed more efficiently by doubly linked list? So we have a doubly linked list. How doubly linked list can be better than the linear linked list? Means singly linked list. Okay. Deleting a node whose location is given, doubly linked list is better. Singly linked list cannot perform better if the node is last node. Okay, if location is given but location is last node, then that will take order of n time. Otherwise, yes, you are right, that will take for all other nodes, that will take constant time. But still there is a one case, there is a one case that, okay, if that is the last node, then that will take order of n time. Okay, so if we are comparing worst case, then doubly linked list is good at deleting a node, because in doubly linked list, deleting the last node can be order of 1, because we can go back and put the null in the previous node. Okay, so deleting in doubly linked list will always take order of one time, either that is the last node or any intermediate node. Okay, so yes, I can say this is better than this. In deletion, searching an unsorted list for a given item, searching an unsorted list for a given item, searching in both of them will take same time. In doubly linked list also, that will take order of n time to search one element. If I want to search one element, I need to go through all the elements. Either that is linear linked list, singly linked list, or doubly linked list. So I cannot say this is better than this in this case, because both are taking order of n time, both are equal. This is not better. So this is not the answer. Inserting a node after the node with a given location. So they provide us a location. We want to insert a new node after that. So in both of them, I can insert a new node in that case in order of one time. In linear linked list also, I can insert in order of one time. Insertion can be done in order of one time. Either that is the last node even. I can insert in singly linked list in order of one time if that is the last node or any intermediate node. In doubly linked list also, that is order of one. Doubly linked list is beneficial only if you need to access something previous, because that cannot be done in singly one or linear one. Okay, so same. So not better. Doubly linked list is not better than linear linked list. In for this also, they are equal. Traversing the list to process each node. Again, order of n. Both will take order of n. Traversing will take order of n. If you want to traverse all the nodes, if you want to process all the nodes, order of n. So yes, that will take how much? So A is the right answer over here. A is the right answer over here. Okay, fine. So check out this one. Check out. Keep trying, keep replying. Keep trying, keep replying. The people who will fight till the end, till the exam day, they have more probability to get success than the people who are performing better but they leave their study earlier. Okay, fight till the end, please. Go till the end. Prepare, keep preparing till the end of till you are not giving the exam, please. Don't leave your preparation earlier. After giving the exam, then take the decision what you need to do. Should you invest one more year, or should you give up, or should you join NIT if you are getting NIT, or should you pursue from any government college MTech? You can decide there and at that moment, because you have something in your hand. If you think that okay, I have 5,000 rank, let me give one more year, and it's okay to give one more year if I can increase my package 10 times. If you're getting 3 lakh, you can get 30 lakh over there, and you have probability to get 1 CR also. If you are determined to do that, you have opportunity over there. So that decision can be taken at the end, but please don't leave your study in the middle. Keep fighting till the end. In 1500 rank, you can try for NIT and some triple ITs. Okay, what is the answer for here? This one. Okay, this is the last question for today. Last question for today. After that, you need to practice at home. This is the last question. Please try. Please try. Last question for today. I want answer from all the people, but I want the answer from all the people. And again, let me remind you. You may be thinking that okay, why I'm speaking it again and again. That's not looking nice also, but still okay. I need it. That's why I'm asking you. If you find my session helpful, please write in the comment. Go to the comment, not in the chat box. In the comment, whatever you find good in my session, please write over there. This will increase the reach of this session. Please give your time over there also. Okay, before leaving the session, please. Otherwise, okay, this is the last question. I'm waiting for many answers, and then I will solve it, and then we will wind up. That's it. Waiting for many answers. Yeah, Rajveer. Yes. Yes. A for AIR1. That can come. Keep doing, keep fighting, believe in yourself. Whatever the other people are saying, keep believing in yourself, please. There will be one time when you will lose the faith that, okay, I cannot move any further. The people who are moving from that phase further, they are getting actually good rank. The people who are getting below 100 rank, they are saying this thing. They are saying that, okay, there was a time when we were thinking, okay, it's not working anymore, and I'm not able to do give this exam. This time will also come, and please keep doing, keep doing, keep doing, keep doing. Ultimately, you will get the results. Chinmay is asking, is the PYQ solving is enough? PY, if you want below 1000 rank, again, same thing will repeat. How many times you will ask me? Because I'm just talking based upon what happening in the gate exam. So if you are giving PYQs, if you are solving PYQ, 20-year PYQs, I can give you guarantee that you will get below 1000 rank. You will get below 1000 rank. If you are solving all the 20-year PYQ, last 20-year PYQ. Okay, but I can guarantee till 1000 rank. Okay, if you want below 300 rank, you need to solve two test series. You need to solve two test series. How? Give that mock test, analyze it. Give the mock test, analyze it. Give the mock test, analyze it. This format. Give the subjective test, give analyze it. Give the subjective test, analyze it. Give in this way. Okay, and if you are doing this, I can give you guarantee you will get below 300 rank. If you want below 100 rank, please mark the questions where you are making silly mistakes, like you are making mathematical silly calculations. You are not reading the problem statements properly. You're getting afraid of the question, some of the question, mark them also. Go through them also. If you're working on your silly mistakes, 100% you will get below 100 rank. There is no magic is going on in gate. There is no magic is going on. Everything is predefined. How much you are doing, that much rank you are getting. Okay, fine. Okay, let me wind up this session now by solving this question. People are replying A. Let's check out A is the right answer or not. Yes, A is the right answer. Let me check out. So here they provide us a doubly linked list, and this is the doubly linked list. Okay, in we have two pointers here and one value. Yes, one is back pointer, one is forward pointer. Fine. So the question is where forward and backward represent the forward and backward link of adjacent element in the list. Okay, we know this thing. Which of the following segment of code out of these code, which of the code delete the node which is pointed by X? So let's suppose this is the node pointed by X. So if we want to delete the node pointed by X, we want to delete this node, then which of the statement can help us. Okay, and it is assumed that x points to neither the first node nor the last node. So x is not the first node, x is not the last node, x is somewhere in the middle. So which statement can help us? So people are saying a, let's see, go through that itself. They are saying, they say that go back of the back is actually is having address of this node, and in the back of the x, go to the forward. So go to the forward of this area. In this area we need to store something. We are talking about this area, about in this. Okay, what we are storing here is we are storing x forward. X forward is actually address of this node. So here we store the address of this node. So we link this thing. Means if here is 5,000 addresses here, we store it here by executing this statement. Yes, this we need to do. And what else we are doing? X forward, we need to link now this also with this back, because this is a doubly linked list. So this is what we are doing here. X forward is this. Actually, forward is having the address of the next node, and its back is this area. In this area we are putting x back. X back means address of this node. X back is this address of this node. Yes, so simply, yes, you people are right. We are actually attaching the back node of x here with this statement, and with this statement we are attaching this with this. Yes, A is the right answer. Yes. Okay, that's it for today. I'm giving you some one question from homework. You need to give the answer that in comment section. Okay, uh, so not this one. Let me give you some nice question. Hmm. This question is also a good one actually. You can take the snapshot of this one. Take this one also. This is a very nice question. You can take the snapshot. This question usually I have seen many people, they ask in product based companies also this same question. In interview they ask this question. Nice question. You can attempt it, and you can give the answer in the chat box. Not this one is that much nice question. Not this one. Then this one. This one is not that much good one. Not this one. Not this one. Yes, this question is very nice. Take this one, please. Take this one. This is very nice question. I say beautiful question. Beautiful. Beautiful question. Even beautiful than any girl also. Very beautiful question. Please answer this question in the comment section. Okay. Okay. Otherwise, you can take the snapshot. And otherwise, thank you everyone for being with me throughout the session, complete session from last 3 hours. You are people are with me, working with me. That's what really nice. That's great. And thank you everyone. Best of luck for your preparation. Best of luck. So I'm now ending the session. Thank you everyone. Have a nice day. Bye bye.